test this. I think it's working. I don't know, like 6 days, I guess, whatever. And then I don't have the screen up. I'll go through the ECMA, whatever, JavaScript standards and update my blah blah blah. So I'm tired of like finding and replacing and updating every place where a 4-byte integer type is used. So I'm gonna figure out how, well, I've used canvases in HTML before, but like I don't like the HTML canvas because it sucks. I don't know. The divs and positioning, that sucks too, but it's more fun than using a canvas in HTML. So I'm gonna use Chatbot and try to make like a little scene or whatever in JavaScript in the browser. I'm gonna have Chatbot make like a camera element or whatever you want to call it, and then bind user input. I'm hoping Chatbot will be able to do most of this. And then I don't know, I'm gonna get that in the browser, and then I will get a variant of it. I have to figure out how to run a standalone graphics whatever without the browser, and then I'll attach my JavaScript engine to that, and I can compare the two. Yeah, basically that's about it. I have to like get this computer started up too. If this computer started up. The bitrate is already like failing, so whatever. And turn the computer. I need to get a different motherboard for this potato CPU. This motherboard is it's abysmal. Seriously, it's do not buy. Do what you want. It doesn't matter. In my opinion, Dell. Well, I think you know what I'm gonna say about Dell computers, but yeah, this is a Dell computer, so I'm gonna like the SATA connectors on it are so loose. I'm gonna wiggle around the SATA cable in a minute. I'm gonna get whatever on the Mac. I want to use PC, but I'm streaming on the PC, so I'm going to use a separate computer. And this Mac is whatever. The Mac isn't really for programming. It's good for web design, but not like programming. Like the only thing the Mac is, I don't know, that whatever, it doesn't matter. Web design's easier on the Mac than on PC. All the libraries and stuff. I don't know, Linux and stuff. I don't know if this Mac I'm not sure if it can really handle a separate 4K display. It's a 1 gigabyte video card. I'm really pushing the limits here. We'll just zoom in, I'll just take a screenshot. That's the wrong keyboard. That's blurry. Oh crap. So running a 4K monitor on this late 2013 Core i5 1 gigabyte I don't know. This computer might just like shut down on me. But Apple does tend to run better than Windows, so maybe it's not gonna just power off and overheat. But the newer Macs I've had, they don't survive to just burn out. It's ridiculous. This computer's a survivor. The new guy after Steve Jobs, he sucks. Nice job. Making some shit computers. Anyways. I gotta like get chatbot stuff. This is like a newish OS X install. Or Mac OS install. Is OS X just aim the app or whatever? The phone. I don't know. Doesn't matter. Well, it does matter. They're different operating systems because they don't know how to write a single operating system for two separate devices So they have to make two completely, entirely different operating systems because they don't know what they're doing. So they are the Mac OS and the phone OS, two completely different operating systems. And then Swift, that's a joke. They can't even. That's the dumbest programming language. It's not the dumbest, I take that back. It's one of the dumbest. I gotta just not stall and waste time. I hate using Opera. It's so bad. I don't want to use Chrome because I'm logged into everything. It's gonna like show my address or some shit. I might need to drop the scaling on this monitor to 2K. I probably should anyways. The capture card's like 180, I don't know. This is like an NZXT 60 capture card, whatever. They claim that you can send 4K video and then you can see on the output of it the 4K video, but it doesn't do that. It sends like 180p video. So you send 4K video into the capture card and then the video through it, the video out, so you can so you don't have to waste two ports sending video. You pass it in the pass through, whatever. It's like 180p. Unless it's just me and my specific product. And it might be because it's a Mac, but it seems like that's what it does because the signal that comes from it always seems to be 180, even though I can send 4K into it. So I don't know. These capture cards are a scam. It's bullshit. So I don't know how it looks. In OBS, it shows a preview, the streaming software, but it's going to be compressed, sent to YouTube. They're going to compress it. I'll just scale it to 2K. Now everything's all blurry. I'm going to scale it back to 4K. Okay, really? I'm doing this document. It's not really for streaming. You shouldn't be watching this. You have a life. Go live your life. Just get out of here. Don't watch this. Okay, now I got that out of the way. I should plug in that hard drive and figure out why it's not being detected. I don't even know. Nothing's gonna work anyways. Okay, so... Okay, oh man. Okay, so since I'm using this computer as a computer the computer I'm showing or whatever, now I can't put down in the other window the EMAC, the ECMA 262, because that's what I was using this computer for. This really mixes up everything. I'm so confused. So I should get ready. I can't even talk. I'm so tired. I'm gonna get Siri reading this stupid standard as I use Opera. Oh, this is horrible. What did it do? It opened like a split screen. I don't want that. I just want the desktop view or whatever. So I'll get, what's up with Walmart? It's like the only thing advertised. It's like Walmart. That's not Walmart. Yeah, it is. Walmart business. I have never gone to Walmart.com. Does Walmart even exist still? Okay, yeah, I have no idea. Everything's messed up. I can't focus. This sucks. So, I'm gonna have to make, I don't have anything on this computer. I don't have any code. This is a new install. I'm gonna have to make an HTML file, a CSS file. I have to get to open and Opera, so I'm gonna have to like set Opera as the main browser so it won't keep going to Chrome. I gotta make a HTML file, what is it, HTML5? I gotta put the doc type 5. It would be more work to pull up an old hard drive and get an existing website. I have some websites on this computer, but first I gotta get it to boot. I gotta wiggle around the SATA connectors. I don't want to do that, so I will make a new web page HTML document, and I'll make a canvas on it, and I'll just get asking chatbot questions, and I'll make like a little 3D box or something with a camera attached to it, getting keyboard input, so you can move the box around. So I guess I will do that, and then I need Siri to read the ECMA or EMCA, whatever it is, 262. I don't have anywhere to, I could take a screenshot of the ECMA and then put it on this computer, so when I switch, that's a lot of work. What I should do is take a screenshot and then go over to the computer I'm streaming on and then upload the image and just put it down there in the corner. That's going to involve effort too. I'm going to have to get a flash drive. There's none on my desk right now, so I would have to find one. All of this involves work, and it's very distracting. So I'm just gonna start off by getting Siri to read whatever. I'm gonna play some music, try to focus, and I'll make a folder on the desktop, I guess, with the HTML file, some CSS, make a canvas, get like a script attached, make it do hello, like alert hello world or something, and then I can go to chatbot and start figuring out how Canvas works again. and I gotta figure out. I got a lot of stuff, just like setup wise, even like computer or whatever wise, streaming wise. Yeah, I'm gonna just do stuff, and at some point, I'm gonna be like, oh, I'm prepared. Look at this, what I'm doing. I should have did all this before I started streaming. But I'm just going with the flow. And right now it's not very smooth, so whatever. I'm gonna stop talking, get Siri to read its documentation. I should stop calling it stupid documentation. It probably offends people. Well, I don't know if they know they're stupid. I don't know. So, I'm gonna stop talking. And try to like make a stupid folder, everything I just said. I feel like I'm forgetting something. Eventually I'll remember it. So I don't know. Hopefully in like 2-3 hours maybe I'll have like a little demo whatever with canvas elements, and then what's the website for I haven't done web in a long time. It's there's a website where you run JavaScript on the server, and then I'm drawing a blank. I don't know. There's a. Let's go to this website. I just want something with like split screen or whatever. Okay, so like this has nothing to do with compilation and stuff. But like let's say like this is the left side, this is the right side. I'm gonna get a game demo so I can run the same JavaScript, the web browser, whatever JavaScript, and then my JavaScript engine. I don't know why I opened this web page with nothing to do with anything. It just has a left side and a right side. So in a couple hours I'll have a little demo hopefully. And I will be able to, if the left side is the modern browser, I'll be able to run my demo in the modern browser over on the left side. And it'll have a frame rate, and then there'll be time for JavaScript to do stuff between those frames. And I can compare that to my JavaScript engine if it's on the right side. To compare, I have to find an equivalent to Canvas. I think I know what it is. I could explain it, but there's no point. I should just do it. So I'm not going to explain it. But I have to find out how to attach it to the C runtime. But then I'll run my JavaScript engine and the render or whatever to make the same output. That way, the modern browser will render a 3D scene with the frame rate. My JavaScript engine will be attached to, I think it's OpenGL, it might be Vulkan, I don't know, whatever it is. I don't think it's DirectX. It'll be attached to whatever. It'll compute the same stuff, do the same thing, but it's gonna be using my JavaScript engine, and then I can compare between the two, whatever, which one is able to do more computation between frames. Okay, so I think I simplified it. I don't know, I'm trying to talk. I don't have the camera on. I have so many things plugged in to this computer that having an extra camera plugged in, OBS, the streaming software, it just poops out. I can't handle it. So I'm not going to plug in a camera. I'm trying to talk with my hands, and like opening up this window is the best I can do. It's really difficult to like explain things when I don't have my hands to like explain what I'm saying. I'm just like talking to a computer screen, and all I have is this in front of me. Like, I don't know how I'm supposed to like get anything across with just my voice. I don't know if that makes any sense. I should plug in the camera. I'm so tired though. I don't want like video of me looking exhausted all over the internet, because I'm really tired. And I'm gonna get to work now. I think I explained everything the best I could without actually showing my face or hands to like explain things. Yeah, I'm done stalling. I'm gonna try to do something. In summary though, I don't even have to summarize it. I pretty much said everything. Oh, but I don't think this decompiler, not decompiler, this compiler, explorer, whatever you want to call it, I don't think the C#, we put C# code in here, I don't know, the output for that, it seems like some bullshit, because when you test the timing and stuff, I don't know. This compiler, explorer, whatever you want to call it, it's supposed to show the source code, the assembly instructions that are generated when you type stuff on the left hand side. Depending on the windows, you can swap them around. We have different windows, it doesn't, whatever. But I think these instructions that it gives are biased, because when you like test it, it's not always accurate. C++ seems to be accurate-ish, but freaking, what is it? C#. Oh, I don't want to scroll through all this. I don't know. Somewhere in this option in C#, I'm not gonna get added a whole bunch of options. But the C# output, I don't think it's legit. So that's another whatever, I don't know. I'm gonna actually stop talking and try to do something. I should have set stuff up before stream. Like I really should have. Why is it not zooming in? I guess I just get super tiny text then. That's great. Yeah, I should have set stuff up beforehand. But I didn't, so I'm just gonna roll with it. So I get Siri reading this poopy documentation in. This video card isn't doing that bad for 1 gigabyte at 4K and the second 2K display, and they both have a 10-bit color, except this late 2013 20-inch iMac. It has a better display than this LG ultra-fine 10-bit display. This Mac has like the most beautiful display ever. It's only 2K. It's really sharp though, but the color is like perfect. Like I can like compare. I'm trying to talk. I don't have hands. I don't have a camera. I should turn on the camera. I'll do that eventually. Like if I compare the iMac screen to the LG ultrafine screen. The blacks on the iMac are like deep black. The blacks on the ultrafine whatever, there's bleeding with the color, and you can like see where the light is distributed behind the screen, and it's like unevenly distributed, and there's like little ripples. You can like see that on the LG ultrafine. But on the Mac, it's just deep black, and the whites are like really bright. On the ultrafine, the whites they're not white, they're like a little bit off. I don't know, when this computer dies, I'm gonna have to get another one. I think it has a BenQ display. I should just buy separate. I'm gonna stop getting distracted at this point. I'm done being distracted. So I'm gonna have iMac read this up. sending the audio.
Context-free grammar.
Oh, now it's sending a thing.
The number of productions. Each production has an abstract symbol.
This streaming software is really buggy. I think it's working.
Terminal and terminal symbols as its right-hand side. For each
I'll check in a minute. I'm already distracted.
terminal symbol on its right-hand side along with 0 or more terminal symbols. Starting from a sentence consisting of a single distinguished non-terminal, called the goal symbol, a given context.
I don't know why the Mac keeps opening GarageBand. It just... God. It lags the whole computer.
The production for which the non-terminal is the left-hand side, 1.2 the lexicon.
I think it says program. I have this on, and it's some... Yeah, it does. What the heck? That's annoying.
Point 1. It defines a set of production.
So I toggle this here, whatever. If I click GarageBand.
E-L-E-M-E-N-T, capital R-E-G.
So GarageBand, it's not open. And I go over here, whatever. I turn on audio input, and GarageBand will turn on. But it goes to the other monitor.
Input elements. Input elements other than white space and comments form the terminal symbols for the syntactic grammar for ECMAScript.
So GarageBand is closed. And I turn it on. And then it's on the other monitor. I guess it won't go to this one. Well, now I know why GarageBand keeps opening.
1-0. Simple white space and single line comments are discarded and do not appear in the stream of input elements for the syntactic grammar. A multi-line comment, that is, a comment of the form comma regardless of whether it's...
So that's a start. I'm gonna plug in those hard drives, I guess. Well, they are plugged in. I'm gonna pull them out, plug them in again, and see if it's gonna detect it or not. Because if it doesn't detect it, it's not gonna boot. Because it's not detected.
It is given in 2-2. 2.
And then I think I'm all set up to actually stream now.
Of productions, starting from the goal symbol pattern that describe how sequences of code points are translated into regular expression patterns. Productions of the lexical and regexp grammars are distinguished by having 2 colons, a separating punctuation. The lexical and regexp grammars share some productions, 1.3 the numeric string grammar. A numeric string grammar appears in 7, 1, 4, 1. It has as its terminal symbol's source character, and is used for translating strings into numeric values starting from the goal symbol string numeric literal, which is similar to but distinct from the lexical grammar for numeric literals. Productions of the numeric string grammar are distinguished by having 3 colons, as punctuation, and are never used for parsing source text. 1.4 the syntactic grammar. The syntactic grammar for ECMAScript is given in clauses 13 through 16. This grammar has ECMAScript tokens defined by the lexical grammar as its terminal symbols. 5, 1, 2. It defines a set of productions, starting from two alternative goal symbols script and module that describe how sequences of tokens form syntactically correct independent components of ECMAScript programs. When a stream of code points is to be passed as an ECMAScript script or module, it is first converted to a stream of input elements by repeating. This stream of input.
I really want a computer. Oh, it's not booting. I have computers that work. This one doesn't work because it's a Dell, so whatever. But what I want is an iMac with a 10-bit display. I've been waiting years, and they will not release an iMac with a 10-bit display. That's all I want. I just want an iMac, a new one, with a 10-bit display. Okay, I'm gonna rant a little bit, because it's not gonna hurt at this point, whatever. I'm way off topic anyways. So, back to the 10-bit display thing. Oh, I'm not gonna use Chrome. So Apple.
The parser are never reused between parsers even of identical source text. Parse node.
If I remember correctly, this was the last 10-bit display, and they said, do you want the iMac with a 10-bit display or Retina? And then Retina replaced the 10-bit display. And the Retina looks like crap. All of the Retina displays, they look like crap. Especially whatever the new iMac is. The separate display is a joke, I don't know. Apple last.
Productions of the syntactic grammar are distinguished by having just one colon as punctuation. 2. Copyright sign. ECMA International 2024.
So the last 10-bit display was 27-inch iMac Pro. This was 17. Did it have Retina with 10-bit?
Parse node. An instance of the generalized.
Okay, I can't waste forever on this. So I'll just waste a second or two and then I'll whatever.
Then, we refer to that instance of n, a parse node, unique for a given p, as the n that is covered by p. All early error rules for n and its derived productions also apply to the n that is covered by p. Otherwise, if the parse fails, it is an early syntax error, 1.5 grammar notation 5. 1. 5. 1 terminal symbols. In the ECMAScript grammars, some terminal symbols are shown in fixed width font. These are to appear in a source text exactly as written. All terminal symbol code points specified in this way are to be understood.
Support for millions of colors.
Whose terminal symbols are individual Unicode code points. That is.
Does it not say 10-bit color in the documentation?
width code points appearing in a production is a simple shorthand for the same sequence of code points, written as standalone terminal.
It's not worth digging into.
Static grammar, a contiguous run of fixed width code points is a single terminal symbol. Terminal symbols come in two other forms. In the lexical and regexp grammars, Unicode code points without a conventional printed representation are instead shown in the form ABBREV, where a
What's this model called? Whatever. It's like a 2023 or 2024.
as they refer to the non-terminals of the same name in the lexical grammar. ECMA International 2024-13. 5. 1. 5. 2 non-terminal symbols and productions. Non-terminal symbols are shown in italic type. The definition of a non-terminal, also called a production, is introduced by the name of the non-terminal being defined followed by one or more colons. The number of colons indicates to which grammar the production belongs. One or more alternative right-hand sides for the non-terminal then follow on succeeding lines. For example, the syntax
Chatbot would know. So it says chatbot.
states that the non-terminal while statement represents the token while, followed by a left parenthesis token, followed by an expression, followed by a right parenthesis token, followed by a statement. The occurrences of expression and statement are themselves non-terminals. As another example, the syntactic definition, argument list, assignment expression, argument list, assignment expression, states that an argument list may represent.
Okay, it says implies. Well, what does that mean?
That is.
So it has a 10-bit display color panel. Physically.
Common, 1, 5, 3 optional symbols. The subscripted suffix opt, which may appear after a terminal or non-terminal, indicates an optional symbol. The alternative containing the optional symbol.
Chatbot's thinking. It's thinking. I've really asked it a good question here. It's trying to come up with some bullshit. Now there's some, I won't say some, someone of a specific ethnicity that you would assume, not to be stereotypical, is probably sitting at a computer right now in their, I spell physical right? I don't know. And they have like a pop-up that says, someone asked this, what do we reply with? And they're like, I don't know, does it have a 10-bit color display panel? And then they're right now on the internet. They're like, quick, look this up, let's send an answer. So they go to Google, and then they're like, it is capable of 10-bit. But it's not though. Something went wrong with this response. We'll just tab not. This is why I don't like Opera on the Mac. It doesn't. There it goes. Help OpenAI. Okay. Do I get paid to help OpenAI? Let's retry this. Are you serious? I can't answer a question? This is what it gets stuck on, of all the things it can get stuck on. I don't think it's technically a template display on the new Macs. I think they play games with the display rate and they fake 10-bit color. It's not really, but then they're like, well, you can't really perceive it because it goes so fast that you think your mind thinks it's 10-bit color. Because that's what this LG ultrafine does. It's not true 10-bit color. So I'll ask this again, and I'm gonna give up on this because if chatbot can't answer it, I'm not gonna bother. Okay, so next question. Okay, I guess it does is answer. Can't answer it. Okay, so it says, and this is where things get nuanced. I don't like the word nuanced. It's so annoying. Like, chatbot will output nuanced with like everything. Okay, so the M3 M1 does not have a true 10-bit panel, but rather an 8-bit plus frame rate control. Which means the new Macs, they're not 10-bit color. And I want a Mac with 10-bit color because this fake 10-bit, it looks nothing like true 10-bit color. Like side by side, it looks nothing like it. It can't display overbling colors. It simulates extra color depth by rapidly flickering between nearby color shades to fake the in-between colors. This is what chatbot says. It's very hard to see the difference. Are people blind? For most users, you can fucking see the difference. And Apple calibrates their displays so well so that it's near pro grade quality. Okay, I'm like done complaining, whatever, but I want an iMac with 10-bit color. When that happens, I will throw this computer out and we'll get that computer. But until then, I'm gonna stick with this iMac. Cause I can like, it doesn't matter. Like doing like web design, anything color related. You wanna print like stuff. Everything's stupid.
And to infinitely
Whenever they release a 10-bit display though, I'm gonna get it. I think this computer is going to live forever though. It's made it so far. I got 24 gigs of RAM in it. Yeah, 24 gigs. I have more than that, but it doesn't seem to detect it. But it's more than 8. So
its decimal digit. The definition.
alright, I think I'm like actually make a web page now or a HTML file and get chatbot. I still gotta boot the other computer. It's still like blinking. It's not. Yeah, okay. So I'm like making an HTML file. I think I have Sublime installed on this computer. I do not. Oh, it is. Okay, good. That saves me a couple minutes of time. This looks so much better on Mac than on Windows. This is so smooth and nice, clean. So, I'm gonna make where did my folder go? So inside this folder, I'm gonna make HTML file, JavaScript file. I have to find the doc type. I think it's just. So I'm gonna like just get started or whatever. If I'm talking, I'm not even gonna talk about what I'm supposed to talk about. So I'm gonna just stop talking and make a demo or whatever. I think I'm gonna look up what I need to make it run in a C program first. I'll do that. I'm gonna do whatever. I can't explain what I'm gonna do because I'm gonna just change my mind anyways. So I'll let Siri read this amazing documentation. So like, enjoy that, and then I will make a little demo so I can like show that the JavaScript engine I made in 2018, I think, that it's the fastest JavaScript implementation above all the current JavaScript implementations. It is really fast. And it has no memory leaks like other. Wait, is this the old documentation? Yeah, here it is. So the current documentation for JavaScript implementations, I think I have to like say the same stuff every couple of streams because I wouldn't watch my streams and you shouldn't watch my streams. You have a life. Stop watching this. Go live your life. I need to stop like streaming and just document and live my life and get to work. But the current JavaScript implementations, they say blah 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 blah, unlikely, a weak map, whatever, to be collected and could leak memory resources in implementations. So my JavaScript engine is different. It's like actually high performance and it doesn't have memory leaks and stuff. That's probably
Maybe
one of the reasons why it's faster. That's not the reason. If I explained all the reasons, everyone would have a fast JavaScript engine, so I'm not gonna explain those reasons. for that reason. But the things that would make JavaScript engines faster are literally like so blaringly obvious, but nobody does anything about it. So it just it's not fast and it's slow. So I'll just leave it at that. But I think seriously reading.
Are typically referenced using a method app.
Yes, Siri's reading it. So I'll let Siri read this modern documentation. I like the word modern. It really describes the current state of modern itself, because everything's just so modern. So I'm gonna look up some crap on getting a 3D render or whatever to attach to C, and then I can get my JavaScript engine to do the same thing as whatever the browser does. So I'm gonna do something I can't pick what I'm gonna do first. I'll just pick as I go with it.
Recognition of the alternative and have no effect on the associated semantics for the alternative. Syntax-directed operations are invoked with a parse node and, optionally, other parameters by using the conventions on steps 1, 3, and 4 in the following algorithm. Let status be syntax-directed operation of some non-terminal. Let some parse node be the parse of some source text. Perform syntax.
I might get a faster computer. I don't know. Programming on this Dell, it's fucking hell. I don't know if it's worth the suffering to use this computer. It's a fucking potato. It is so bad. It works because I can tell what code runs best, because it's such a bad computer. It has such a small cache on board and stuff on the die. It's got 32 gigs RAM, so it's like it's so quirky. I don't know. I think I'm gonna use the potato just because it's fun. Because it's a potato. I don't know. But I really like OS X and the text editor, and like everything is just so clean, smooth, sharp, and precise compared to this Dell Windows 11 potato. So I'm gonna like just absorb, enjoy my time on the iMac again, and then I'm gonna go back into code optimizing mode and use this potato computer on purpose because it's easier to optimize things. I've explained that before too, so I won't explain that again. I'm gonna take a break. A short one. I just need water. This isn't gonna boot, but that I like the blinker. It's kinda cool. I hate web design. I kind of hate everything, so I don't know. I'm gonna have to just accept it, bottle up this hatred, and get to work now. I just wasted so much time setting the stream up, complaining and bitching. I need to stop. So I'm gonna stop and I'll be back. I really want people to stop watching the streams. Just like, go away. Leave. Stop it. Go away. So, I hope that was cringy enough to make you like GTFO, like, go away. Just leave. Go. I don't want to whisper into the mic because that is actually really cringy. So I won't do that. I'm gonna actually take a break now. Because I don't need people watching. I don't need that. I don't need anything. Literally, I don't want to monetize. I don't want to explain why I don't want to monetize. But, it's all pointless. I said, I shouldn't foreshadow things, so I'm just gonna BRB.
These cases are when the result of applying completion, normal completion, or throw completion is directly returned.
Man, everything's like messed up because I was using this Mac. It's like a screensaver. Now I'm using it as the main computer, so.
True or let completion be normal completion. True, return.
To like drag these windows back and forth. If they update this standard, the 2024 standard, to 2025, at some point, this is 2024, if they do that, well, I'm gonna have to start over again from the top. So hopefully they don't, but if they do, I'm gonna, whatever. It could be worse, you know. They might. If they do, it's gonna suck. But most of it will be the same, so. I'll just Google it really quick.
Of the production, static semantic rules have names and typically are defined using an algorithm. Named static semantic rules are associated with grammar productions, and a production that has multiple alternative definitions will typically have for each alternative a distinct algorithm for each applicable named static semantic rule. A special kind of static semantic rule is an early error.
Fuck!
Productions. Evaluation of most.
Ah, oh, damn it. There's already a 2025?
Module. If any of the early error rules have violated, the script or module is invalid and cannot be evaluated. 2.5 mathematical.
How many standards do they have? They already starting 2026? Who's gonna waste their time keeping up with these standards? These people are insane. Their standard sucks. How is it 2026 already out? It's not even 2026. Oh, it's a draft. I want the PDF. Where the heck is PDF? Oh, this browser is so slow. Where's the PDF?
Its most new values in base 10. It also uses numeric values of the form 0x followed by digits 09 or ref as base 16 values. When the term integer is used in this specification, it refers to a mathematical value which is in the set of integers, unless otherwise stated. When the term integral number is used in this specification, it refers to a number value whose mathematical value is in the set of integers. Conversions between mathematical values and numbers or big ints are always explicit in this document. A conversion from a mathematical value or extended mathematical value x to a number is denoted as the number value for x or x, and is defined in 6, 1, 6, 1. A conversion from an
Where the fuck is the PDF?
mathematical value of x or r, x. The mathematical value of plus 0 and minus 0 is the mathematical value 0.
Huh?
Otherwise is x itself. The mathematical function min, x1, x2, xn, produces the mathematically smallest of x1 through xn. The mathematical function max, x1, x2, xn, x1. The domain mathematical functions are the extended mathematical. And x, k equals q1.
This isn't a single page. Wait, is it? Don't look for the word leak. It says we're leaking it. Okay, is this 2025 or 2024? This is just stupid. Okay, so is this here, this website, the 2026 revision? It says this EMAC standard defines the EMAC 2026 language. But when you go to the website over here, it says it's 2024. In the PDF, it says 2024. And they don't have a 2026 PDF. You know what, I'm gonna figure this out later. This is confusing. I don't want to like have to update this engine 24/7. For fuck's sake. I just want to write it once and be done. So I'm gonna have to like come up with a way to add extensions to the engine so I won't have to code it all the time. That will slow it down, but I'm doing that because I'm not writing code for every single update. I'll meet whatever the PDF is. Because like this website, they could just keep updating it every day and something could change in the documentation. And I was looking at the other day and it could, I don't know. I'll figure this out later. I'm gonna just get the browser to make a little game demo in the Canvas HTML5. This Canvas, the CSS3 thing. Whatever it is. Oh, baby.
Hedge or the length of a sequence. Values without identity may be manifest without prior reference by fully describing their characteristics. In contrast, each value with identity is unique and therefore only equal to itself. Values with identity are like values without identity but with an additional unguessable, unchangeable, universally unique characteristic called identity. References to existing values with identity cannot be manifest simply by describing them, as the identity itself is indescribable. Instead, references to these values must be explicitly passed from one place to another. Some values with identity are mutable and therefore can have their characteristics except their 24. Copyright sign, ECMA International 2024. Identity, changed in place, causing all holders of the value to observe the new characteristics. A value without identity is never equal to a value with identity. From the perspective of this specification, the word is used to compare two values for equality, as in if bool is true, then, and the word contains is used to search for a value inside lists using equality comparisons. As an if list contains a record are such that are, from the perspective of the ECMAScript language. Language values are compared for equality using the same value abstract operation in the abstract operations it transitively calls. The algorithms of these comparison abstract operations determine language identity of ECMAScript language values. For specification values, examples of values without specification identity include, but are not limited to, mathematical values and extended mathematical values, ECMAScript source text, surrogate pairs, directive prologues, etc., UTF, 16 code units, Unicode code points, enums, abstract operations, including syntax-directed operations, host hooks, etc., and ordered pairs. Examples of specification values with specification identity include, but are not limited to, any kind of records, including property descriptors, private elements, etc., parse nodes, lists, sets and relations, abstract closures, data blocks, private names, execution contexts and execution context stacks, agent signifiers, and waiter list records. Specification identity agrees with language identity for all ECMAScript language values except symbol values produced by symbol 4. The ECMAScript language values without specification identity and without language identity are undefined, null, booleans, strings, numbers, and big ints. The ECMAScript language values with specification identity and language identity are symbols not produced by symbol for and objects. Symbol values produced by symbol for have specification identity, but not language identity. ECMAScript data types and values. Algorithms within this specification manipulate values each of which has an associated type. The possible value types are exactly those defined in this clause. Types are further subclassified into ECMAScript language types and specification types. Within this specification, the notation type X is used as shorthand for the type of X, where type refers to the ECMAScript language and specification types defined in this clause. Point 1. ECMAScript language types. An ECMAScript language type corresponds to values that are directly manipulated by an ECMAScript program using the ECMAScript language. The ECMAScript language types are undefined, null, boolean, string, symbol, number, big int, and object. An ECMAScript language value is a value that is characterized by an ECMAScript language type, 1.1. The undefined type. The undefined type has exactly one value, called undefined. Any variable that has not been assigned a value has the value undefined. 1.2. The null type. The null type has exactly one value, called null 6, 1. 3. The Boolean type. The Boolean type represents a logical entity having two values, called true and false. ECMA International 2024-25. 6, 1. For the string type. The string type is the set of all ordered sequences of 0 or more 16-bit unsigned integer values. Elements, up to a maximum length of 253 elements. The string type is generally used to represent textual data in a running ECMAScript program, in which case each element in the string is treated as a UTF-16 code unit value. Each element is regarded as occupying a position within the sequence. These positions are indexed with non-negative integers. The first element, if any, is at index 0, the next element, if any, at index 1, and so on. The length of a string is the number of elements, that is, 16-bit values within it. The empty string has length 0 and therefore contains no elements. ECMAScript operations that do not interpret string contents apply no further semantics. Operations that do interpret string values treat each element as a single UTF-16 code unit. However, ECMAScript does not restrict the value of or relationships between these code units, so operations that further interpret string contents as sequences of Unicode code points encoded in UTF-16 must account for ill-formed subsequences. Such operations apply special treatment to every code unit with a numeric value in the inclusive interval from 0xD800 to 0xDBFF, defined by the Unicode standard as a leading surrogate, or more formally as a high surrogate code unit. And every code unit with a numeric value in the inclusive interval from 0xDC00 to 0xDFFF, defined as a trailing surrogate, or more formally as a low surrogate code unit. Using the following rules, a code unit that is not a leading surrogate and not a trailing surrogate is interpreted as a code point with the same value. A sequence of two code units, where the first code unit C1 is a leading surrogate and the second code unit C2 a trailing surrogate, is a surrogate pair and is interpreted as a code point with the value C1 0xD800, 0 times 400 plus C2 0xDC00, plus 0 times 10,000, C1 1, 1, 3. A code unit that is a leading surrogate or trailing surrogate, but is not part of a surrogate pair, is interpreted as a code point with the same value. The function string prototype normalize, C22, 1, 3, 1, 5, can be used to explicitly normalize a string value. String prototype locale compare, C22, 1, 3, 1, 2, internally normalizes string values, but no other operations implicitly normalize the strings upon which they operate. Operation results in not language and or locale sensitive unless stated otherwise. In this specification, the phrase the string concatenation of A, B, where each argument is a string value, a code unit, or a sequence of code units, denotes the string value whose sequence of code units is the concatenation of the code units. In order of each of the arguments, in order, the phrase the substring of S from inclusive start to exclusive end, where S is a string value or a sequence of code units and inclusive start and exclusive end are integers, denotes the string value consisting of the consecu type code units of S beginning at index inclusive start and ending immediately before index exclusive end, which is the empty string when inclusive start equals exclusive end. If the to suffix is omitted, The length of S is used as the value of exclusive end. The phrase the ASCII word characters denotes the following string value, which consists solely of every letter and number in the Unicode basic Latin block along with U+005F. Low line. Abdefkajakamnopkrestavwexes abdefkajakamnopkrestavwexes 0123456789. For historical reasons, it has significance to various algorithms. 1. 4. 1 string index of string search value from index. The abstract operation string index of takes argument string, a string, search value, a string, and from int x, a non-negative integer, and returns an integer. It performs the following steps when called. Let len be the length of string. If search value is the empty string and from index len, return from index. Let search len be the length of search value. Note the rationale behind this design was to keep the implementation of strings as simple and high-performing as possible. If ECMAScript source text is in normalized form C, string literals are guaranteed to also be normalized, as long as they do not contain any Unicode escape sequences. 6. ECMA International 2024. 4. For each integer I such that from index I len, search a len, in ascending order, do a let candidate be the substring of string from I to I plus search len. B if candidate is search value, return I, return -1. Note 2 this algorithm always returns -1 if from index plus the length of search value, the length of string, 1.5 the symbol type. The symbol type is the set of all non-string values that may be used as the key of an object property. 6. 1. 7. Each possible symbol value is unique and immutable. Each symbol value immutably holds an associated value called that is either undefined or a string value. 1. 5. 1 well-known symbols. Well-known symbols are built-in symbol values that are explicitly referenced by algorithms of this specification. They are typically used as the keys of properties whose values serve as extension points of a specification algorithm. Unless otherwise specified, well-known symbols values are shared by all realms. 9.3. Within this specification a well-known symbol is referred to by using a notation of the format @name, where name is one of the values list. Ed in Table 1. Table 1. Well-known symbols. Note 1 if search value is the empty string and from index the length of string, this algorithm returns from index. The empty string is effectively found at every position within a string, including after the last code unit. Specification name, description, value and purpose. @async iterator, symbol async iterator, a method that returns the default async iterator for an object. Called by the semantics of the for await of statement @has instance, symbol has instance, a method that determines if a constructor object recognizes an object as one of the constructor's instances. Called by the semantics of the instantia operator @is concat spreadable, symbol is concat spreadable, a Boolean valued property that if true indicates that an object should be flattened to its array elements by array prototype concat. @iterator, symbol iterator, a method that returns the default iterator for an object. Called by the semantics of the for of statement @match, symbol match, a regular expression method that matches the regular expression against a string. Called by the string prototype match method. Copyright sign, ECMA International 2024. 7. Table 1. Well-known symbols. Continued. Specification name, description, value and purpose. @match all, symbol match all, a regular expression method that returns an iterator that yields matches of the regular expression against a string. Called by the string prototype match all method. @replace, symbol replace, a regular expression method that replaces matched substrings of a string. Called by the string prototype replace method. @search, symbol search, a regular expression method that returns the index within a string that matches the regular expression. Called by the string prototype search method. @species, symbol species, a function valued property that is the constructor function that is used to create derived objects. @split, symbol split, a regular expression method that splits a string at the indices that match the regular expression. Called by the string prototype split method. @toPrimitive, symbol to primitive, a method that converts an object to a corresponding primitive value. Called by the toPrimitive abstract operation. @toString tag, symbol to string tag, a string valued property that is used in the creation of the default string description of an object. accessed by the built-in method object prototype to string at unscopables, symbol unscopables, an object-valued property whose own and inherited property names are property names that are excluded from the with environment bindings of the associated object. 1. 6 numeric types. ECMAScript has 2 built-in numeric types, number and bigint. The following abstract operations are defined over these numeric types. The result column shows the return type, along with an indication of it is possible for some invocations of the operation to return an abrupt completion. Table 2. Numeric type operations. Operation. Example source. Invoked by the evaluation semantics of result. Number. Unary minus x. Unary. Operator. Number. Bigint. Unary minus bigint. Number. Bitwise not x. Bitwise not operator. Number. Bigint. Bitwise not bigint. Number. Exponentiate xy. Exponentiation operator and mathpal. Base. Exponent. Number. 28. ECMA International 2024. Table 2. Numeric type operations. Continued operation. Example source. Invoked by the evaluation semantics of result. Bigint. Exponentiate. Either a normal completion containing a bigint or a throw completion. Number. Multiply xy. Multiplicative operators. Number. Bigint. Multiply bigint. Number. Divide xy. Multiplicative operators. Number. Bigint. Divide. Either a normal completion containing a bigint or a throw completion. Number. Remainder. X% y. Multiplicative operators. Number. Bigint. Remainder. Either a normal completion containing a bigint or a throw completion. Number. Add x plus 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 x plus y. Postfix increment operator. Prefix increment operator. And the addition operator. Plus number bigint. Add bigint. Number. Subtract x. xy. Postfix decrement operator. Prefix decrement operator. And the subtraction operator. Number bigint. Subtract bigint. Number. Left shift x. Y. The left shift operator. Number bigint. Left shift bigint. Number. Signed right shift x. Y. The signed right shift operator. Number bigint. Signed right shift bigint.
Alright, I'm gonna get this potato running. And when I said it's all pointless, I was talking about uploading videos to YouTube, not the JavaScript engine. That's not pointless. If this was pointless, I would not be programming right now. I'd be doing anything else other than programming. This totally has a point. There's a freaking mouse is not working.
Via is strictly equal x, y, b. Right sign. Operation. Example source.
I think I gotta make like 3 more stupid playlists.
Via same value x, y.
Now I'm going through this documentation, whatever. Put that in like a separate playlist, and then the stuff after that in its own playlist. So like maybe I'll like call the playlist ECMA 262 2004 language spec. And if there's another like 2026 whatever,
String. Argument. String.
I guess just make another playlist, and then whatever changes that were between whatever the last version was, I'll just make a video and show that it meets whatever for that part of the standard. So maybe I could update this from time to time. I don't know. I gotta get it to meet the standard first, and have to get this other computer to turn on. I gotta get HTML document, so on. So I'm gonna stop talking, turn this computer on, try to get some documents, make a web page, get it to open. Then I'll get chatbot, then the canvas stuff, make like a box. I already said this before. So whatever I said last time, earlier in this stream.
Infinite number values are produced by the program expressions plus infinity, or simply infinity and infinity. Note the first and subsequent editions of ECMAScript have provided, for certain operators, implicit numeric conversions that could lose precision or truncate. These legacy implicit conversions are maintained for backward compatibility, but not provided for BigInt in order to minimize opportunity for programmer error, and to leave open the option of generalized value types in a future edition. Note the bit pattern that might be observed in an array buffer, C25.1, or a shared array buffer, C25.2. After a number value has been stored into it is not necessarily the same as the internal representation of that number value used by the ECMAScript implementation. 0. Copyright sign, ECMA International 2024. Note that there is both a positive 0 and a negative 0. For brevity, these values are also referred to for expository purposes by the symbols +0 and -0, respectively. Note that these two different 0 number values are produced by the program expressions +0, or simply 0, and -0, the 18, 437, 736, 874, 454, 810, 622, that is, 264, 253, 2. Finite non-zero values are of two kinds. SM2, where s is 1 or -1, m is an integer in the interval from 252, inclusive, to 253, exclusive, and e is an integer in the inclusive interval from -1074 to 971. The remaining 9, 007, 199, 254, 740, 990, that is, 253 2, values are denormalized, having the form SM2, where s is 1 or -1, m is an integer in the interval L from 0, exclusive, to 252, exclusive, and e is -1074. Note that all the positive and negative integers whose magnitude is no greater than 253 are representable in the number type. The integer 0 has two representations in the number type, +0 and -0. A finite number has an odd significand if it is non-zero and the integer m used to express it, in one of the two forms shown above, is odd. Otherwise, it has an even significand. In this specification, the phrase the number value for x where x represents an exact real mathematical quantity which might even be an irrational number such as b, means a number value chosen in the following manner. Consider the set of all finite values of the number type, with -0 removed and with two additional values added, to it that are not representable in the number type, namely 21,024, which is +1 times 253 2,971, and -21,024, which is -1 times 253 2,971. Choose the member of this set that is closest in value to x if two values of the set are equally close. Then the one with an even significand is chosen. For this purpose, the two extra values 21,024 and -21,024 are considered to have even significance. Finally, if 21,024 is chosen, replace it with plus. If -21,024 is chosen, replace it with. If +0 was chosen, replace it with -0 if and only if x, 0, any other chosen value is used unchanged. The result is the number value for x. This procedure corresponds exactly to the behavior of the IEEE 754-2019 round ties to even mode. The number value for plus is plus, and the number value for is semi. Operators deal only with integers in specific ranges such as the inclusive interval from -231 to 231
I'm gonna try, I guess, to use this computer here through the streaming software because I can't find another HDMI cable or DisplayPort to HDMI cable. I don't think it's possible to do that. On the modern operating system, it should be possible to send video like one display to another display wirelessly. Just, that'd be great. I'm gonna have to find a cable then. I'm not gonna rant about the modern operating system. It's probably gonna get old at some point. I don't know. They're not modern though. I'm getting tired of saying the word modern. It's not fun anymore. It's like, we all know the operating systems suck. There's no point in me pointing it out. But there would be a point in making a better operating system. Who knows? Maybe one day that might happen. Who knows? Who? I don't know. Maybe one day. Maybe more modern than this. One day.
Assert.
But who knows?
0 if exponent is plus, then if abs r base 1 return plus b if abs r base equals 1 return nan c if abs r base 1 return plus 0 0 if exponent is then if abs r base 1 return plus 0 b if abs r base equals 1 return nan c if abs r base 1 return plus 1. Assert. Exponent is finite and is neither plus 0 nor minus 0. 2. If base minus 0 and exponent is not an integral number, return nan.
If I unplug an HDMI cable or DisplayPort cable from the streaming computer, last time everything, the whole computer went down because OBS was running, and it the computer started screaming a sound. I was like, I'm not gonna make that sound, but it got stuck, and then it gave me a blue screen, and it just went black. So I don't want to risk unplugging anything from the streaming computer because I have a feeling that'll happen again. If I unplug something, it'll just. So I gotta find a cable or something. I'll be right back. computer case is the top slot where the video card is in is too tight for the video card. All the HDMI cables are fat as hell. I can't plug them in to the video card. They don't reach. I plug it in and it detects it, but I can't get the freaking cable in the freaking hole. And the case has like screwless mounting for like add-on cards. I can't wiggle the video card down lower because it's like it locks, it clicks. It's like that's where it goes. I can't wiggle it down. Oh, this is annoying. So I'm just going to ignore the other computer for now. I'm gonna shut it down. I'm gonna focus on the Mac or whatever. And once I get stuff running on the Mac, I'll go over to the other computer or something. If I unplug anything from the computer that's streaming, it's gonna shut down and it's gonna just fail. So I guess I'll do that. Yeah, I'm gonna risk unplugging something. I'll see how this goes. I'll just take the risk. Last time, this went really bad. It'll probably go really bad again. Like the computer will probably just shut down or whatever. I unplugged everything, and I think it's actually still working. Nothing crashed. That's great. So everything's unplugged. Nothing crashed. I flipped around cables, whatever. And I gotta restart this other computer anyways because it detected one drive, not the other. So I gotta plug it back in and restart it. And it's turning on again. I'm hoping it's gonna boot. Why is the other monitor? Okay, I think everything's working. Possibly working. Okay, I'm gonna like open up a HTML web page or something, and I'll just have chatbot do everything. Actually, chatbot should be able to do like stuff. I don't know. Chatbot can't do C programming, and it doesn't know how to do pointers and stuff, but it should be able to do web design and like graphic stuff because that's like simple stuff, and it doesn't involve memory structures and keeping track of things. It's like a function call or whatever. You just pass data in. I don't know. I'm gonna stop talking, try to focus. I think everything's working now. I need some more water. And Siri is not Siri ran out of stuff to read, guys. So I'm gonna like pick some more text and read it.
One zero five seven P. The internal method of a proxy exotic object O takes argument P. A property.
Does JavaScript have UFO operator? Is that C++? I don't know, whatever.
Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has if trap is undefined. Then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false. Then a let target desk be target. P. B if target desk is not undefined. Then I if target desk is false. Throw a type error exception. 2. Let extensible target be. Is extensible target 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor. Target desk is true and target desk is false, then I have same value. Trap result. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true and target desk 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9 receiver. The perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. V. Receiver. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024 209. If is data descriptor. Target desk is true and target desk is false, then I have same value. V. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true, then I have target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible target. 1. Let target keys be target. 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key be if desk is not undefined and desk is false. Then, I append key to target non-configurable keys C else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5. Internal method of implements this argument. An ECMAScript.
So first, I'm gonna make a HTML document. Okay, get the doc type Java.
I don't non-revoke.
I could Google it, but ask chat.
Trap, handler, target. This argument, array, note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211, the 10th of May 2013, Arguments List, New Target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let arg_array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Arg_array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0. 5. 1 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P. 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though
I don't have time to like set up Sublime to look how I want it to look. So whatever this is what it is. I don't like this color coding. It's funky, but I'll just deal with it. I'd have to pull up my other Mac, install and like find the preference folder and install packages and stuff. That would take forever, so I'm just gonna work with however it is by default.
code point U+000A is line feed, LF. And
My shortcuts, they also won't work. if I have to spend too long programming in this, I'm gonna have to copy over my preferences and stuff. That'd take like 30 minutes. I just wasted enough time already starting the stream, so I'll like try not to do that, I guess. I don't know. I should stop wasting time so I have more time to not waste. I need that buffer time of wasted time. I'm wasting time right now, so I'm gonna stop, I guess.
Code point and returns a string. It performs the following steps when called. Assert 0cp0 times 10ff. If cp0xff, return the string value consisting of the code unit whose numeric value is cp. Let k1 be the code unit whose n numeric value is floor.
I put the stream too back to a partial color. I don't know. It's weird. Sometimes when I send full color from OBS, it looks okay. But then other times it looks bad. I think... I don't know. I picked partial color, so if it looks funky, I'll fix it next time.
And returns a string. It converts.
It's always gonna look funky. Because, yeah, I'm not gonna waste more time.
Of result and UTF-16 encode code point CP3. Return result 1 1 3 static semantics UTF-16 surrogate pair to code point lead trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead a code unit and trail a code unit and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xd800. 0 times 400 plus trail 0xdc00 plus 0 times 10,000. Return the code point CP 1 1 4 static semantics. Code point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position. Size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then I return the record. CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then I return the record. CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then I return the record. CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record. CP 2 false 1 1 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6, 1, 4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string, position, B append CP to code points, C set position to position plus CP, return code points. 14. ECMA International 2024, 111. 6 static semantics, parse text, source text, goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, and on terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, C 10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code source. Note 1. Consider a text at a later point. An implementation that does a parse.
I can't, I don't know. Normally, I had it set up so the music that I'm listening to would stop playing when I hit to talk. Now I gotta, click on the keyboard to pause music. I'm gonna keep forgetting that too. But, I don't know. I changed the theme to black because white's unreadable when you're trying to read the screen. My eyeballs are burning. I like the white better, unless it's actually trying to read the screen. Then it's the white's too much. So, I'm a little bit more focused now. I'm gonna try to make progress or whatever. And if you're watching the stream, you should stop watching this, go live your life. Just go away. Toodaloo. Okay, so I made it. I don't know. I made an HTML file in Notepad. I asked Chatbot to make a website, whatever. I have to change the default browser to Opera. I should install the new Mac OS, but it'll take time, so I'm not gonna bother. I can't find it in this old layout.
Token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use-strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use-strict or use-strict. A use-strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use-strict directive. However, an implementation may issue a warning if this occurs. 1. 2. Strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4.
This video card is doing really good for 4K. I don't know what. The computer's really hot. I should install like a fan program to turn up the fans, but I don't know. I think it'll make it.
It is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression.
So now the default browser is still Chrome.
Expression, async function declaration, async function expression, async generator declaration, async generator expression.
Oh, I gotta pick this other button. I'm like thinking. I can't really talk as I'm thinking. If I do talk, I'm getting lazy. I'm not gonna finish any of my sentences. So, yeah.
ECMA.
So, Chatbot made the web page with the canvas. It's centered. I don't like the flex things that they added to HTML, but it doesn't matter.
Not have a meaning defined by the implementation. 1, 1, 2, 3 non-ECMAScript functions.
In CSS, whatever, they can't even like standardize border in anything, basically, because Microsoft, nobody uses Microsoft now. They basically screw everything up on purpose, so you gotta like account for the Microsoft browser. And then they like, I don't know, they added a bunch of stuff to account for the old stuff that doesn't work. I don't know, I haven't done web design in a bit. I have a feeling though that the new stuff, properties, whatever, added to CSS, it's gonna have just as many issues, if not more. And then it's like not even compatible or as compatible. But I'm gonna focus on whatever.
I N
So making a web page, I'm getting it to open to Opera. So walk through Chrome.
R E G capital E X.
Now I need to there's like OpenGL. I don't know, I'm just gonna like try to figure out whatever. Either it supports whatever, I don't know. There's like a whole bunch of ways I can do this. I'm trying to like pick the easiest to just get going.
Use of multi
So I'm gonna do that and stop talking for a bit.
that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: a equals b high g exec, c map, d, where the first non-white space, non-comment code point after a line terminator is u+002f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as a equals b high g exec, c map, d, syntax, input element div, white space, line terminator comment token div punctuator right brace punctuator, input element regi xp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white space, line terminator comment token div punctuated template substitution tail.
Okay, so it's not
Regular expression literal. 2.
the feedback in the mic.
Unicode format control characters. That is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark are control codes used to control
Testing.
higher level protocols for this.
Testing.
It is useful to allow format control characters in source text to facilitate editing and display.
Testing.
Used within comments and within string literals.
Testing.
U plus 200C, 0 width non-joiner, and U plus 0 width joiner are format.
Okay, so it's not OpenGL. It's a WebGL.
U plus
We use as a JavaScript binding to a subset of OpenGL. Say what we
characters intended for this purpose can sometimes also appear.
This is a mouthful. So does that mean it has a OpenGL ES 2.0 function call that's bound to JavaScript but is passed into WebGL? Is that what it's saying? So if you're trying to use OpenGL syntax, use WebGL. So it looks similar to OpenGL ES, but it's all done with JavaScript. take a Claritin.
2024, 12.2 white space.
My allergies are killing me.
Indivisible lexical units from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value.
Okay, so this is coming from OpenGL. 3 wrapper. I think this is no, it's not.
Separator USP, note 1 U plus 0020, space, and U plus 00A0, no break space. Code points are part of USP syntax. Note 2, other than for the code points listed in Table 36, ECMAScript white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. Zs 2.3 white space tab VT FF ZWMBSP USP line terminators, like white space code points. Line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. And CR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U plus 000. Line feed. LF. U plus 000 D. Carriage return CR. U plus 2028. Line separator. LS. U plus 2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax, line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF. LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible. A single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax. Comment. multi-line comment, single line comment. 20. ECMA International 2024. Multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars. Capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not, capital M U L T I, capital L I N E, capital N O T, capital F O R W A R D, capital S L A S H, capital O R, capital A S T E, source character but not one of all, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt, single line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in Sec T. On B 1.112.5 hashbang comments. Hashbang comments are location sensitive and, like other types of comments, are discarded from the stream of input elements for the syntactic grammar. Syntax: hashbang comment, single line comment charsopt, 2.6 tokens. Syntax: common token, identifier name, private identifier, punctuator, numeric literal string literal template. Note the div punctuator, regular expression literal, right brace punctuator, and template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221, 12.7 names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31, identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier start, identifier name, identifier part, identifier start char, Unicode escape sequence.
I don't.
Identifier start char,
I can't get what I want.
WJ, assign letter.
I'm gonna have to run JavaScript outside of the browser.
J K L M N O.
I have to set up my mouse too, so I can like flip that steps. I need to think or whatever. I need basically I need to be done like now, like as soon as possible, so I can get back to coding. So I need like whatever would use the least amount of I can't just use I use the browser. This gray box inside the gray box is canvas.
Identify name.
It uses a WebGL. It's not the same as OpenGL.
If a Unicode escape sequence.
So it's not. Any code I write to graphically render. This video card is acting up. I'll see how long it makes it. It's probably gonna overheat. It's already like distorting the display. This work.
Art. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2, 7, 1, 2 statics.
Oh man, which one's the real one?
And returns a list of code points. It is defined piecewise over the following productions. Identifier name. Identifier start. Let CP be identifier code point of identifier start. Return CP. Identifier name. Identifier name identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2, 7, 1, 3 static semantics. Identify.
What the heck is it? It says it expanded it.
The code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point.
Set 80, 96 degrees. Or now it's on a 70, 8, I don't know.
By name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of ECMAScript include if, while, async, await, and many others.
They used to let you make a preset. I guess not anymore. Oh wait, produce maybe. How much is this later? I think I need to run the Chrome JavaScript engine outside of the browser. And then pass it in to OpenGL through a C program. So that's annoying.
And not keywords, such as math, window.
I don't want to write it up the same code twice for two things.
That are contextually allowed as identifiers. namely await and yield, those that are contextually disallowed as identifiers in strict mode code. Let, static, implements, interface, package, private, protected, and public, those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last three categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax: reserved word. 1 of await break case catch class const continue debugger default delete 2 else enum export extends false finally for function of import and instantia of new null return super switch this throw true try type off var void well with a yield 24 ECMA International 2024 note 1 per 5 1 5 keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1.1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13.1.1.8.6.4.1.5.2.1.1.5.5 1.1.5.6.1 and 1.5.8.1. 2.8 punctuators syntax. Punctuator, optional chaining punctuator. Other punctuator, optional chaining punctuator. Look ahead decimal digit. Other punctuator, 1 of, comma equals plus, percent plus, and equals plus equals percent equals and div punctuator equals sign right brace punctuator 2.
Is it Chrome V6 or V8? I don't know. I'll just type in whatever. So I said I want to run OpenGL with systemlog so I can compute stuff in C and pass that to OpenGL API for rendering. How would I set things up so that I can use Chrome JavaScript Engine to do computations for passing into OpenGL API for rendering also. I want to compare the amount of work that can be done. C versus JavaScript between rendered frames. so whatever, and then I want to compare the amount of work that can be done in C versus JavaScript between each frame render, or I don't know, just rendering frames, I guess. I like how chatbot sucks up. It's like, this is a really smart and deep performance question. It's like, no, it's not. Says you want to see OpenGL to do native CPU side work and render JavaScript via Chrome to do equivalent work and still render with OpenGL, ideally native. I think that's what I don't care about thinking right now. So this is what I want, yes. Have Siri read it. I think Siri stopped reading.
Introducing ChatGPT OpenAI. Centered canvas layout. Change default app. Tick. Option 2. Embed Chrome.js engine. V8. Inside C app. This is wild but powerful. You can embed V8. Chrome.
It's wild, but not very powerful. Cause yeah, whatever.
Tick. Option 2. Embed Chrome.js engine. V8. Inside C app. This is wild but powerful. You can embed V8. Chrome's JS engine. Into your C++ program. Use JS to compute things inside your C process. Pass the results directly into OpenGL rendering calls.
Okay, so that's what I have to do then. So I'll make well, I have the JavaScript engine, whatever, already. Is a separate solution project, whatever it's called. So So I just have to I think it's GLFW, whatever. So I gotta get whatever program needed to make a window. And then I can compute stuff in my JavaScript engine and then do work and then send it each frame in the C program. And I'll make a separate C program that's going to embed Chrome into that separate C program, so then I can pass in a string or whatever. It probably takes a string. I would guess it takes a string. It might take a file. I don't think it would take a file though. If it takes a string, I can't just run an outer loop because that wouldn't be fair. Because it would have to dynamically render the string each time. So, I want to get like an actual speed comparison. I need to get whatever program that's used to make the window. I think it's GLFW. I think I used one of them before. I don't remember. It wasn't that exciting. The browser was easier because it doesn't have all the extra crap. But it's a different syntax or whatever. So I'm gonna get this or that. That'll make the window like the window, you know, like a window that has a program. And then I'll get the OpenGL runtime or whatever it's called to have OpenGL to run. And then OpenGL will run inside the window. And I'll have the C program call to like make the screen or the window that whatever blue or purple or something to see if it's like calling the API and the screen's updating, and if the screen changes color, it's clearly working. So I'll make a new Visual Studio project, and I will do this stuff I just said here inside of this new project, and then I can make a toggle, and then I can include the files from my JavaScript engine in a different folder, so it'll all be available in this new project that's going to be used to output to the screen, graphics, whatever. And then I can toggle to pick the other case, which will select using the embedded Chrome JavaScript engine. Then I'll be able to toggle between either running my JavaScript engine or the Chrome embedded engine. I don't need to toggle up because what I really want is two separate functions, and then I can call my JavaScript engine, do some computation, call it to render the frames, and have it output some of the computed stuff to the frame, so like things are like animated to OpenGL, whatever. And then it'll do like a speed test, like it'll run for like 30 seconds or something, and then I can put counters in there to figure out how many times or how much work it did, and then I'll call the JavaScript embedded engine, the Chrome V8, whatever, V6, whatever it is, in the other function, and I'll have it do the same thing, where we'll send data, whatever, to OpenGL to animate stuff on the screen, put counters in it, and then I can like run my JavaScript engine test function and then embedded Chrome V6, V8, whatever it is, engine, and I'll call it like 10-12 times or something, and I'll pick like a random ordering. So it'd be like my engine test, Chrome engine test, my engine test, Chrome engine test, Chrome engine test. So like go back and forth, whatever. And then I'll like average it. I'll pick out the outlier, whatever the max slowest and then max fastest. I'll try to like normalize it, the final output, whatever, data, like fairly, whatever. The only catch is that my JavaScript engine is compiled once because it's in the C program. I started to set up stuff, but I didn't finish it. I have to set it up to call the compiler at runtime and compile stuff. And then it passes back an address that it can run. But I haven't done that yet, or I haven't attached it. So when I make it run my test function, my JavaScript engine won't have to compile the code every single time, every loop. So I'll put like a loop, whatever, on how much work to do, or how much time before it has to stop doing work. Either way, it doesn't matter. But I'll put that like in the C program, but for the embedded JavaScript Chrome V8, V6, whatever engine, I'm pretty sure you pass in a string. That means if I put a loop outside where I'm calling the place that it's embedded at, it's gonna be really slow because it's gonna have to compile it every time. So for the embedded JavaScript engine, that's a Chrome whatever, I'm gonna have to put like the loop counter inside of the script that's running. I'm gonna have to figure out how to pass that data back out from the embedded runtime. I don't have the attention span for any of this, so I will install GLW or SDL2 to just to make the fucking window. I'll make a new C program and I'll make it change the color of the screen, and that's what I'll do for now. And I'll get back to finding and replacing all the 4-byte size T types in my JavaScript engine, and then next stream, tomorrow, whatever, I will I'm gonna have to figure out how to embed Chrome inside of the C app, so I'll be able to compare it. And I could run a test and compare it against my JavaScript Engine now as a 32-bit program. I might just do that anyways. And then I'll compare it to I'll compare it to after I convert it to 64-bit, before I do the standards and stuff, because that'll take months. I want to do a comparison, whatever, before I spend months reading this standard that states that memory leaks are acceptable. It's not going to be like copy, paste, and run. I'm going to debug, install, check, compare, find different, install, check this, check that. So I'm going to download these. I'm going to take a break out of the bag, and then I'll do something. I think I'll just download these two, whatever, or pick whichever one's better. Times it. I don't want to deal with making a new project, and I'll just download them, get them copied over and ready, and then tomorrow I'll make a new project and see, have it sent to make the screen a certain color, whatever. And that'll be it for the day. And the next day I'll download whatever's needed to embed it. P8. This says you need a wrapper duct tape or JS. That's not gonna be fun. I thought there was a way to embed it natively using P8 command line, but I don't want to spend a whole bunch of time investigating everything, which is what I'm kind of doing right now. So I'm gonna take screenshots of chatbot's output. Because I didn't sign in and it's gonna disappear. I'll do that and make it back. Need some water. Too. I don't know. That's what I'm gonna do. I can't spend forever setting stuff up. It's so boring. I have to also finish actually converting it to 64-bit still, so I'll get back to that. I'm gonna wait. I don't know. I'm gonna take a break. I'll be back. I'll take screenshots of this so I don't have to like ask it again. I think that's the plan. And I can compare the two after in like 5 days, 6 days, I don't know. If I can even get done in 5 and 6 days. So, I'll be ready.
Punctuators syntax. Punctuator. Optional chaining punctuator. Other punctuator. Optional chaining punctuator. Look ahead decimal digit. Other punctuator. 1 of, comma equals, equals 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 plus, percent plus plus, and equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. Div punctuator equals sign. Right brace punctuator 2.9 literals 2 9 1 null literals syntax. Null literal null. ECMA International 2024 225 1 2 9 2 Boolean literals syntax. Boolean literal true false 2 9 3 numeric literals syntax. Numeric literal separator. Numeric literal. Decimal literal. Decimal big integer literal non-decimal integer literal. Plus sep. Non-decimal integer literal. Plus sep. Begin literal suffix legacy octal integer literal. Decimal big integer literal. 0 big int literal suffix. Non-zero digit decimal digits. Plus sep opt begin literal suffix. Non-zero digit numeric literal separator decimal digits. Plus sep. Begin literal suffix. Non-decimal integer literal. Sep. Binary integer literal sep. Octal integer literal sep. Hex integer literal sep. Begin literal suffix. N. Decimal literal. Decimal integer literal. Decimal digits. Plus sep opt exponent part. Plus sep opt. Decimal digits. Plus sep. Exponent part. Plus sep opt. Decimal integer literal exponent part. Plus sep opt. Decimal integer literal. 0 non-zero digit. Non-zero digit numeric literal separator opt decimal digits. Plus sep. Non-octal decimal integer literal. Decimal digits. Sep. Decimal digit. Decimal digits sep. Decimal digit. Plus sep. Decimal digits. Plus sep. Numeric literal separator decimal digit. Decimal digit. 1 of 0 1 2 3 4 5 6 7 8 9 26. ECMA International 2024. Non-zero digit. 1 of 123,456,789. Exponent part. SEP. Exponent indicator signed integer SEP. Exponent indicator. 1 of EE. Signed integer. SEP. Decimal digits SEP. Decimal digits SEP. Decimal digits SEP. Binary integer literal. SEP. 0b binary digits SEP. 0b binary digits SEP. Binary digits. SEP. Binary digit. Binary digits SEP. Binary digit. Plus SEP. Binary digits. Plus SEP. Numeric literal separator binary digit. Binary digit. 1 of 0 1. Octal integer literal. SEP. 0 octal digits SEP. 0 octal digits SEP. Octal digits. SEP. Octal digit. Octal digits SEP. Octal digit. Plus SEP. Octal digits. Plus SEP. Numeric literal separator octal digit. Legacy octal integer literal. 0 octal digit. Legacy octal integer literal octal digit. Non-octal decimal integer literal. 0 non-octal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Non-octal digit non-octal decimal integer literal decimal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. 0 octal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Octal digit 1 of 1,234,567. Non-octal digit. 1 of 89. ECMA International 2024 227. Hex integer literal. SEP. 0x hex digits SEP. 0x hex digits SEP. Hex digits. SEP. Hex digit. Hex digits SEP. Hex digit. Plus SEP. Hex digits. Plus SEP. Numeric literal separator hex digit. Hex digit. 1 of 0 1 2 3 4 5 6 7 8 9 abdef a b c d e f. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 1 2 9 3 1 static semantics. Early errors. Numeric literal. Legacy octal integer literal decimal integer literal. Non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code. This syntax is legacy 2, 9, 3, 2 static semantics. MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal integer literal exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer decimal digits is the negative of the MV of decimal digits. The MV of decimal digit 0 or of hex digit, 0 or of octal digit, 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the two input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit. The MV of decimal digit. 6 or of non-zero digit. The MV of decimal digit. 7 or of non-zero digit. The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4. 5 or of hex digit. 5 or of octal digit. 5 is 5. 6 or of hex digit. 6 or of octal digit. 6 is 6. 7 or of hex digit. 7 or of octal digit. 7 is 7. 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits numeric literal separator binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal digit is the MV of capital L E G A C Y capital O C T A L capital L I K E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal, non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit is the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of octal digit. The MV of hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions. Numeric literal, decimal literal. Return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal. Return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal. Return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA interna, Shinal 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit big int literal suffix 1. Return the big int value for the MV of non-zero digit. Decimal big integer literal. Non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the MV of non-zero digit 10n plus the MV of decimal digits. Return z, MV 2, 9. 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMAScript string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2 code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator. ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence, 30, ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 129.3. Source character is defined in 11.1. ECMA International 2024 231. Note 2, LF. And CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000, 2, 9, 4, 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2, 9, 4. To static semantics, SV, the syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 129.3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, LS, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of double string character, PS, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, LS, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of single string character, PS, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000. Null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a useStrict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error. Function in valid 7 useStrict 32 copyright sign ECMA International 2024 Table 38 String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BS T 0 times 0009. Character tabulation. HT N 0 times 000 line feed. LF V 0 times 000B. Line tabulation. VT F 0 times 000C. Form feed. FF R 0 times 000D. Carriage return CR double quote 0 times 0022 quotation mark apostrophe 0 times 0027 apostrophe backslash 0 times 005C reverse solidus comma the SV of non-escape character. Source character but not one of escape character or line terminator as the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence. Legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038. Digit 8, the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039. Digit 9, the SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4. 3 static semantics. MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82. Times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7, the MV of hex escape sequence. Hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit, plus 0 times 100 the MV of the second hex digit, plus 0 times 10 the MV of the third hex digit, plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMAScript regular expression grammar. 2.2.2.1. An implementation may extend the ECMAScript regular expression grammar defined in 2.2.2.1 but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, regular expression char, regular expression non-terminator but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars. Empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminator but not one of, or, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate two regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. C22, 2, 4, 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char 2, 9, 5, 1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1, 2, 9, 5. To static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note 2. Regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use Dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $sign or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead not code point. Hex digits. SEP. But only if MV of hex digits. 0 times 10FF. Code point. Hex digits. SEP. But only if MV of hex digits 0 times 10FF. Note template substitution tailors used by the input element template tail alternative lexical goal 1 2 9 6 1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $, is the string value consisting of the code unit 0 times 0024. The TV of template character, template escape sequences the SV of template escape sequence. The TV of template character, not escape sequence is undefined. The TV of template character, line terminator sequences the TRV of line terminator sequence. 236. Copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences the empty string 1 2 9 6 to static semantics. TRV. The syntax-directed operation TRV takes no arguments and returns str. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $, is the empty string. The TRV of template middle, $, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $, is the string value consisting of the code unit 0 times 0024. The TRV of template character, template escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence. 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit, the TRV of not escape sequence. X, look ahead hex digit. Value consisting of the code unit 0 times 00.
Okay, so I kind of have an idea of what I'm gonna do, whatever. So I'll like explain it, and then I gotta get back to finding replacing. But I need like, I don't think install any ARC programs on this install yet of macOS. So can I draw with this? Got a blank page. Here we go. So what I want is I have a pen tablet that I unplugged a bunch of stuff. Maybe too much work to plug in.
At in small letter.
I just suffer using it. Using the mouse.
X digit, the TRV of not escape sequence.
So I'm just gonna draw.
Is the string C, concatenation of the code unit.
Only highlights. I thought it would like draw on the screen.
7b, left curly bracket, and the TRV of not code point, the TRV of not escape sequence. U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075.
Oh, there it is. Oh, why is it arrow? I want like just not arrow.
Code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character. One of BFNRTV is the result of performing UTF-16 encode.
Redacted content. Oops. I don't know what I'm doing. I didn't mean to redact anything. I'm gonna screw this. I'm gonna have to download this kind of thing.
Latin small letter X. The TRV of the first.
Just let me draw on the document.
The TRV of Unicode escape sequence. U hex 4 digits is the string. The TRV of Unicode escape sequence. U, code point, is the string concatenation of the code unit.
I'll change the color.
Curly bracket, the TRV of ECMA International 2000. Digit is the string concatenation of the T.
Why is it making a shape?
The TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. Is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, a B, C, D, E, F, A, B.
It's wasting time, so
Line termination.
Let's say that this blue thing,
05C.
let's say this is the C program. Blue, and then green will be, man, this is freaking now. That's inconvenient. I gotta like pick the color after I place it.
0 times. Line separator. The T.
Okay, let's say this green thing is C program.
2020.
I want to run so the green is a C program.
Line feed 2.10 automatic semicolon insertion. Most ECMAScript statements and declarations must be terminated with a semicolon. Such semicolon.
I thought it would make a shape. I guess not. Let's say that this is my JavaScript engine, and it's I've never used threads in C yet. I have in C#, so I'm not sure how threads work in C totally. In C#, they seem a little funky. So this is all hypothetical, okay? I have to like get into it. I don't even know if threads are needed. I just want to like, I need to be able to like, I'm just gonna explain what I want. Hypothetically, technically speaking, I gotta figure out as I go when I start doing it, whatever. But here's what I want. I want a function like this blue, whatever here. If this is like the code for my JavaScript engine, I want a function inside of the C file. This is green. And then I want another function for the Chrome, what was the word? Whatever it's called when you run Chrome inside of C. They have a wrapper program for it. Make this like purple. Or I guess that's purple. Super light purple. So this is my JavaScript function. API, whatever. And this is the Google Chrome JavaScript function API. So I gotta start drawing first to pick the color. So let's say like this is the work to do. The yellow. I want to like set a number, whatever. So maybe like random particles, or I'll have cubes or characters, just something that's rendered that blurps. That means like moves back and forth on the screen. Just a bunch of stuff moving in the scene. I also want the input though for the user, so make that big brown, I guess. I don't know, running other colors. Let's say this is like the keyboard. This is like the mouse. I want those in JavaScript Engine. Man, this is just not doing what I thought it would do. Okay, so the keyboard and the mouse, they go in to the C program. And I'm gonna have whatever is being rendered, seeing whatever, like the environment, the workload is right here. So the mouse input and keyboard will like control looking around in the game or whatever. I'll just call it the game, the 3D environment. And the yellow will be like whatever's going on in the 3D environment. So it's like you're just spectating or something. But I want lockstep is clearly the worst way to like need some water. Lockstep is like the worst way to handle frame rate because it'll finish early and then there's wasted time. But then
No line terminator here.
as long as it finishes early, the frames will be stable.
Plus await.
So I'm going to use it lockstep on purpose for that reason. Because I want to increase like the workload, whatever, by some number, whatever, like scale it. So like increase to like 2, 4, 8, 12, 10, I don't know. Make it bigger so it does more work. And each like hypothetical thread, if this is how the threads actually work in C, I don't know till I try it. And I want to make sure that the threads they run fairly and they don't compete for memory and stuff. Because if one takes priority over the other, it defeats the point of comparing the two, because it's not a comparison. So I might need to make 2 separate programs that go to one program and then send stuff to a file and have it read from there. But that I'm trying to hypothetically make it simple. So let's say that hypothetically threads are how they seem to be. So as I increase workload, the more work, whatever, each of the threads will have to do, because they're each running, they're computing the scene, the 3D environment that's navigated with the mouse and the keyboard over here. So as the work increases to compute the environment, maybe it'll make more particles, like it's a particle simulation, or I'll have like little boxes like moving around. It'll do more stuff, whatever. And as it does more stuff, if it takes longer to do each time, if I lockstep it and do 60 frames per second, and I check the frame buffer, so each of these will have a frame buffer, whatever.
S are followed by a line terminator before it equals token. A semicolon is automatically inserted in the punctuator, causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted in the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon.
Okay, so each thread runs hypothetically, independently, assuming they're not gonna compete for resources, and the work's gonna be fairly distributed. If it doesn't happen to be that way, I'll have to come up with a new way to test this stuff. But my JavaScript engine will go to 1 frame buffer. The Chrome V8 engine, whatever, JavaScript engine, will render to its own buffer. So as this workload increases, it'll take longer or shorter, depending on if it's increased or decreased, to create these frames. So the longer it takes to make a frame, the longer it takes to make a frame. It's like very simple. So if it takes more than a 60th of a second to generate a scene, a frame of the environment of all the stuff going on based on the workload amount and the mouse and keyboard being used to navigate the environment, so it's interactive too. Then it's going to be missing frames, because if it takes 2/60ths of a second each time, you're going to get 30 FPS because the workload is too large to be computed between frames. That's why I'm using lockstep, for example, on purpose, to figure out like what point the workload takes a hit and how dramatic the difference is between the two. And then on a side note, I might also make a third thread. That's not a square. Oh, come on. I guess it's just gonna keep doing this then. Oh, there it goes. So on a side note, I'm gonna make possibly a third thread in C that will also make its own frame buffer, whatever. So I can compare C, plain C, to my JavaScript engine, to Chrome V8 engine, and then I can tell how closely my engine is to the C runtime, because my engine's in C. Well, I actually made an arrow, so I can compare I just said whatever. Okay. So I'll put this over here. Okay, so basically, as I said, the more workload, at some point, it's going to affect the 60 frames per second. I can pick more than 60 frames per second. It doesn't matter. This is just hypothetical example, whatever. But I'm not sure how OpenGL, if I can call OpenGL from separate threads at the same time, or if it's I need what's it called, a lock, or not a memory barrier, whatever the word is for it, a mutex. I think it's a mutex. I don't know if I need a lock or a mutex to control entering to call the OpenGL routine, which does the graphics, whatever, to pass in and have it generate the frame, which is why I'm being hypothetical. But hypothetically, if you don't need a mutex and everything just runs threaded, hypothetically, as we think it would, and neither of them get like an unfair advantage in performance, and it's like a good baseline for comparison, hypothetically, if it doesn't work that way, I'm gonna have to adjust this whole plan that I'm making, which is why I'm gonna wait till this tomorrow. But hypothetically, they would both, my JavaScript engine and the Chrome engine, would output to OpenGL, and then I could like set a value or something to say it's complete, the frame's complete, and it's ready to be displayed. and then I can run down here, whatever, like an overall OpenGL instance that's tied to the main window. So the main window, the main frame buffer, whatever, would be this one, whatever, like 60 FPS, whatever, and it would check these frame buffers from both separate threads, each running individually, hypothetically, of course, if this is how I already explained, whatever. And it would take, when it signals that it's ready, the frame, so like I could like draw like a line down the middle of the overall window, and then I could put every time the frame's ready on the 60th of a second, I'll have it update to like the left half of the screen on this side, whatever, and then this side it would update to the right hand side of this frame buffer, so I can see. Dang it. This way I could see each thread running side by side, and then when the workload up here, whatever, increases, at some point the slower one which is going to be Chrome V8. The slower one though, you're going to see the frame rate drop on that side of the screen. So overall, I'm going to increase and decrease the workload of the environment as it's running to see how much work it can do until the frame rate's affected. The mouse input, keyboard, whatever will navigate the environment. The compute environment is going to be computed on my JavaScript Engine, Chrome V8. They're each going to go to their own frame buffer. I'm going to have a overall frame buffer that'll check the status to display every 60th of a second, the next frame, each time, whatever. So as the environment gets more complex, it won't be able to update fast enough to keep up with the frame rate, so the frames will drop because it's lockstep. So at some point, the frames will begin to drop. It's going to be in Chrome because it's slow. It's a terrible JavaScript engine. They're all terrible. So the frame rate is going to drop if Chrome is on the right hand side of the screen. Can I get another arrow? Possibly. So if Chrome is on this side, whatever, the frame rate is going to start to drop as this workload increases. And then I can look around in the environment with the mouse and keyboard over here to like look up, down, look left, right, whatever, and you'll be able to see whatever that it's dropping, that I'm walking in the environment, like how real game is. And then as I increase this rate, workload, whatever, it will eventually affect my JavaScript engine. But when will it affect a JavaScript engine? I don't know. So if it takes let's say it's like I have a sliding scale, I set it to 2 to 4, and when I hit 8, JavaScript starts dropping frames. I can go to 10, 11, 12, increase this workload, 13, 14, 15. Whenever Chrome starts to drop, it's going to continue to drop slower and slower and slower. 17, 18, 19, 20, whatever, as the environment variable workload goes up. So as Chrome drops in frames, mine will drop whenever it hits enough workload to actually drop. So it is totally possible that Chrome could run at 1 frame per second or 1 frame per 30 seconds by the time my JavaScript engine is actually like affected by the scale of work it has to do in the environment, or my JavaScript engine will like take a hit too at some point and it won't be a huge difference. But my gut tells me that there's gonna be like a massive speed difference, and if there is a massive speed difference, I'm gonna say mine's twice as fast. I'm not gonna show how much faster it is because that doesn't matter. All I want to prove is that it's faster. The amount faster, that doesn't matter. But I do want to compare against the C runtime. That's where I'm gonna say like the difference. So like I'm gonna run my JavaScript engine, 2 frame buffer, and then a normal C program where I'll run the JavaScript as C. And I'll put that to separate frame buffer, and then I'll increase this workload, whatever. And then I'm hoping that as I increase the workload, they sort of like both the C version and my JavaScript engine, they both start to get hit in the frame rate at the same time. Because if they do, it means that my JavaScript engine is close to C runtime computation. So I will tell the difference for that, because I don't know. That's like, I don't know. It doesn't relate to competition with JavaScript because I'm comparing it to C, which it's in C, if that makes sense. So then I will know how close or how much of an impact that my JavaScript engine has, how much overhead compared to a normal C program. And it could also happen to be true that somehow my JavaScript engine, as I increase workload and stuff or decrease it, it's not selecting now. It's also possible that as I increase workload, the C program, whatever, buffer, frame buffer, it might actually get a performance hit first and start dropping frames. Because I have like caching and stuff that C doesn't normally have. So if the caching works, it might actually outperform normal C program. And if it does outperform a normal C program, I'm not gonna say how much. I'll just say they're the same speed. So when I do this test, whatever, the only like actual like the weighted speed difference, whatever, I'll share is the C program, or the JavaScript, my JavaScript engine versus normal C. How much faster it is or whatever compared to normal C, that doesn't matter, so whatever. And when I compare my JavaScript engine to the Google Chrome V8, V6, whatever it is, when I compare to that, if it's more than twice as fast, that doesn't matter. I'm just gonna say, look, it's more than twice as fast. So overall, hypothetically, I'm probably gonna have to like change this plan. I might need 2 separate programs running 2 separate processes, but this is what I'm aiming for. And then I can have like a nice clean like single window where it's like left side, right side, and I could even like toggle it so it shows only one frame buffer or only the other, or both, like split down the middle. But then it's like it's all compact, and I don't know, it seems like a good way to like test stuff and compare. I don't know. I'm gonna think about it. If I come up with a better way to test and compare, then I'll do that. But did it just delete all my stuff? Oh, it's still here. Let's see. It's a mess, but yeah. So what I'm going to do now, though, is I think I spent 20 minutes explaining that. I'm talking into a microphone. I don't have hands or whatever to take show. Even if I talked with my hands, it's hard to explain. So I think that explained it, whatever. So I'm going to do this right after I'm done converting it to 64-bit. I might test it before. I'll just wait until I'm done, because it's just going to delay getting it running 64-bit. So today I'm gonna finish on this computer, whatever. It's a mouse. I'm gonna finish, try to finish in a couple hours, finding all the types and stuff, tagging them to use the new keyword for the type, so I can toggle to pick between 64-bit or 32-bit type. I have to finish doing that because there's a couple left, like corner cases that I gotta account for. So I'm gonna try to do all those today before the end of the stream. And tomorrow, if I can get all of these done, whatever, all the types tagged, all that's left is address arithmetic. Then I'll get into address arithmetic. I need water. And once all the 32-bit address arithmetic has been updated to 64-bit addressing arithmetic, then I can run it, and I think it'll have a couple issues where it's using up more memory than it should. I may have to like double check some things. It's complicated. At that point, or a couple days after, I have like, this is day 6, I don't know. I want it to be done in 2 weeks, so like 5 more days after today. If I can get all this done in what I just said, with the address and the types. If I can get that done in 5 days, then I will be doing this. But I'm gonna try to like just install this tomorrow, not today, because I just wasted time explaining this. So tomorrow I'm gonna like install this, and the next day I'll install where is it? The next day I'll install duct tape, QuickJS, or V8 Go, so I can embed. That's the word I looked for earlier. Then I can embed. I'm talking too fast. Then I can embed the JavaScript engine inside the C program to do this on separate threads. If the threads hypothetically work as they seem like they should work. And then I'm gonna install OpenGL, whatever. I'll try to get the threads running, get it rendering, and I'll deal with input. So like I can do like a couple of these things, like one thing, 5 days, whatever. I could do like this, then the other thing, split it up, spend like an hour maybe over the next 5 days, and then that way it won't be like all in one day. I'll split it up. I'll do the address arithmetic for the rest of those 5 days. But then at the end of the 5 days, I should be close to having most of this like written up and ready to go. Because I'm gonna do like little bits each day, and if it's not done on day 0 by when I want to be done with the address arithmetic, then I can spend a day or two finishing up this stuff and making sure that it's a fair comparison and stuff.
Capital A.
And then I can run this, compare them, blah blah blah. So after that though, I kind of proved whatever that it's faster than Chrome, and you could say I'm lying, you can say whatever, it doesn't matter, because it's facts, whatever, when I run it. And I don't know till I run it too. All I know right now is that it's really, really fast, and I'm betting it's whatever. And it should be able to handle games. It handled big data and number crunching, so I'm pretty sure it can handle games. But that's why I want to do this, whatever, to find out for sure. So after that though, I proved whatever stuff, and with this is the documentation. Then after I like all this stuff, whatever, I show demos and stuff. I don't know how advanced I want to get with the demos. I'm gonna think about it. Like a little cube is fancy, but I might want like a video game character or something. Maybe I can find like what's it called?
Does not include property names defined using a computed property name. 13253 static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is
these little animals, whatever. on DLC website, the Big Bunny animation, whatever. I think that they're for Blender. You can download them, or like
List of property definition list. Let prop name be prop.
please respect.
If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5 for runtime semantics.
People have some pretty like disturbing looking Shrek models in Blender. I don't want to make one. I want to find one. If I have to give credit, I'll give credit. I don't care. So like, I don't know. I might have some fun with the game demo or not. I don't want to waste too much time, but it'd be funny. So maybe I'll have like a bunch of Shreks running around or something. I don't know. Because OpenGL is like a full-fledged thing, so I could do rendering. All this stuff involves work. I might just do like basic cubes and not get fancy or try to be funny. But this is kind of funny if I could do this. If I could get like Shrek in there, or if I like put little characters. So, I don't know how fancy I'm gonna get with it, but I'm planning to at least keep it simple for now. Or I could just keep it simple and then maybe like after a month of this documentation, I could like get fancy with it and like spend time doing more testing or whatever. So after this stuff is done, next 5 days, hopefully I can run tests and show whatever. But after that, I'm gonna go through this documentation and top to bottom. And then after I go through this documentation, I add support, everything in its met, then I'll have a full-fledged JavaScript engine. And then I can compare the JavaScript engines again afterwards. It should still be faster. I don't know why it would be slower. It'll probably be like the same exact speed faster. Unless I test like specific calls or whatever, which I might do. I might want to do like integer testing, string testing, I don't know. I don't know. That's the plan. So hopefully in 5 days I can have this all done in the program in 64-bit, and then I can hit the standards here for 2 months, and then I'm gonna spend hopefully not too long accounting for things outside of the standard. I talk fast or really slow, there's no in between. Everything outside of the standard after. So like right now I'm calling the videos prologue. That's all this whatever. I'll change the videos to like chapter or something, for when I'm going through the chapters of this standard. And then after the standard, I'm gonna call it epilogue, because I'm gonna be like cleaning up stuff, adding browser support and whatever. It's I don't know, it's complicated. And I don't know, that's the plan. I think this will save. One like delete some executables.
Copyright sign, ECMA International.
There's a whole lot of talking. I need some water. I'm gonna take like a 2-minute break. I gotta like collect my thoughts again. I'm going to, though, I'm going to take screenshots of these answers, whatever, so I don't have to look them up tomorrow. And tomorrow, like I said, I'm gonna download something, or both, just get stuff like downloaded and on the computer. And then over the next couple days, 5 days, whatever, I'll work on getting towards this overall setup, whatever. But I'm mainly going to be, hopefully, doing address converting, 64-bit. Because I can't do that until I get the types. So right now, I'm going to get the rest of the types tagged, marked, and using the new type name. And now I'm going to do the addressing, like I said. So, I think I covered everything. If I didn't, I'll say it eventually at some point, whenever I remember it. But this is just resize. Come on, click.
R-E-G-U-L-A-R, capital E-X-P-R-E-S-S-I-O-N, capital L-I-T-E-R-A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more.
Testing.
Flags contains U, let U be true.
So I'm gonna move all this stuff to the other desktop. I gotta like unplug this one or plug another one in. So I'm not gonna use this webpage or whatever. I'm gonna do what I said. I have to run Chrome or whatever in the C program instead of in the browser. So I'm not gonna be doing the browser thing then. It'll be in the C program. So I don't even need this, whatever. Let's just close it. It's been like 40 minutes.
Let flags.
I'm gonna like screenshot this stuff.
Create. 2, 8.
Then I'm gonna put it on the BRB screen and unplug a couple monitors, move stuff around. Then I'm gonna get to like doing whatever I was doing yesterday with the stupid types.
Spans. Yield. Await.
So I'm gonna do that now and stop talking.
Yield await tagged. Template tail. ECMA International 2000.
Screenshots first. Question.
Middle list yield await tagged. Template middle expression. Plus in yield await. 3, 2, 8, 1 static semantics. Early errors. Template literal. Yield. Await. Tagged. No substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains. Not escape sequence. Template literal. Yield. Await. Tagged. Substitution template yield await tagged. It is a syntax error if the number of elements and the result of template strings of template literal with argument force is greater than or equal to 232. Substitution template. Yield. Await. Tagged. Template head expression. Plus in yield await. Template spans yield await tagged. It is a syntax error if the tagged parameter.
I scrolled too high. Dang it. I'm gonna screenshot down here too now.
Tail. It is a syntax error if the tagged Parameter was not set and template tail contains not escape sequence. Template middle list. Yield.
I could probably just grab the text, but
Await. Template middle list.
this is easier to see. It's a literal picture file,
Tagged. Parameter.
so I won't have to worry like the text encoding or whatever, or like the formatting not looking the same.
Template string.
This is easier. Just take a bunch of pictures.
Undefined. It is.
I need some water. My mouth is so freaking dry. Can't even talk.
Substitution template. Raw. Substitution template. Template.
Water. Okay, I got screenshots. And I'm gonna unplug stuff, plug it back in, shuffle the computers around, get on this computer, finish up these types. And then tomorrow I'll start on this stuff, whatever. No, did it disappear? Oh, it's gone. Oh, that's weird. Oh, this is a browser. And tomorrow I'll work on this a little bit, whatever. This, whatever. I think that's everything. Let's see if this is useful. Oh, this is gonna be useful. Super fancy.
There's a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook string. Count 232 1. Let.
Okay, so I'm actually gonna be back in a second, but if this was like lockstep or whatever, when the workload increases, you get slower and slower and slower. I don't know. I think I explained everything, like, brutally simple. I think. So it should be, I don't know. I'm tired of explaining. So in a couple days, I should go prove the proof is in the pudding. Or in the potato. I don't even know what I'm saying. It's just freaking. I'll be right back. Like screenshots, everything's good. I'm gonna put this monitor over here. I do feel like I've got to say something, but I'm gonna get to like the stupid types and finishing up stuff on this computer now, so I'll be right back.
Template token contains a not escape. Note 1 the create.
I was still reading, okay. It's probably gonna run out of text to read soon. The browser though, it looks like it runs almost the same speed as it did 8 years ago. So, I don't know. I'm really glad that nothing has changed. It's pretty cool. So, I'll be back.
1.3.2.8.5 Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let preceding be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3, 2, 8, 6 Runtime semantics. Evaluation. Template literal. No substitution template. E. Return the TV of no substitution template as defined in 1.2.9.6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1.2.9.6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3 future editions of this specification may define additional non-enumerable properties of template objects. Note 1 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1.2.9.6. Template spans. Template middle list. Template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1.2.
I didn't actually get up yet. I'm trying to check some stuff. I should actually BRB and set the timer again. Okay, like BRB.
B. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1.2.9.6. Let subref be. Evaluation of it.
I just think like I'm still here, I'm just not here screen. It's like different than a BRB. It's kind of the same thing. I don't know.
Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. To runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. capital A, N. Let expa be the parenthesized expression that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return. Evaluation of expa, parenthesized expression, expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type-off may be applied to parenthesized expressions. ECMA International 2024 257 13.3 left-hand side expressions syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus in yield await. Member expression yield await. Identify name member expression, question mark yield await, template literal yield await, plus tagged, super property yield await, meter property, new member expression yield await, arguments yield await, member expression yield await, private identifier, super property, yield, await, super, expression, plus in yield await, super, identifier name, meter property, new target, import meter new target, import meter, import meta, new expression, yield, await, member expression yield await, new expression yield await, call expression, yield, await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression, plus in yield await, call expression yield await. Identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await. Private identifier, super call, yield, await, super arguments yield await, import call, yield, await, import, assignment expression, plus in yield await, arguments, yield, await, argument list yield await, argument list yield await. 58. ECMA International 2024. Argument list. Yield. Await. Assignment expression. Plus in yield await. Dart. Assignment expression. Plus in yield await. Argument list yield await. Assignment expression. Plus in yield await. Argument list yield await. Assignment expression. Plus in yield await. Optional expression. Yield. Await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain. Yield. Await. Arguments yield await. Expression. Plus in yield await. Identifier name. Template literal yield await. Plus tagged. Private identifier. Optional chain yield await. Arguments yield await. Optional chain yield await. Expression. Plus in yield await, optional chain yield await. Identifier name, optional chain yield await, template literal yield await, plus tagged, optional chain yield await. Private identifier, left-hand side expression, yield, await, new expression yield await, call expression yield await, optional expression yield await. Supplemental syntax, when processing an instance of the production, call expression.
I don't know if I can focus today. I'm so distracted. I'm actually gonna get up and take a break now. was trying to check something, and stupid keyboard. That was way too much thinking. I was like planning out all this shit. I gotta do it. I gotta like think about it. I got a headache. I might actually need 10 minutes. Whenever I find my way back to the computer, that's when I'm back. Hopefully sooner rather than later. But it is what it is.
N D capital A S Y N C capital.
Like write a JavaScript engine from scratch, and then like think about it. You know, it's a whole bunch of little bitty pieces. It's really, really complicated. When I say it's simple, or I'm making a joke, it is not simple. It's freaking complicated. Okay, I'll okay.
And automatic semicolon insertion rules 12.1.
And that standard freaking sucks. Okay, now I'm a baby.
So that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter, import meta. It is a syntax error if the syntactic goal symbol is not module 1.3.3 to property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3, 2, 1 runtime semantics. Evaluation. Member expression, expression. Let base reference be. Evaluation of member expression. Let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R. Base value, expression, strict, 60. ECMA International 2024. Member expression, identifier name, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N. Base value, identifier name, strict member expression, private identifier, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference. Base value, field name string. Call expression, expression. Let base reference be. Evaluation of call expression, let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier let base reference be evaluation of call expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R takes arguments base value an ECMAScript language value expression an expression parse node and strict a boolean and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key, property name value. Return the reference record. Base value. Property key. Strict. This value. Empty. 3, 4. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N takes arguments base value an ECMAScript language value identifier name an identifier name parse node and strict a boolean and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name. Return the reference record. Base value. Property name string. Strict. Empty. ECMA International 2024 261 133 5 Then new operator. 3 3, 5, 1 runtime semantics, evaluation, new expression, new expression, return, evaluate new expression, empty, member expression, new member expression arguments 1, return, evaluate new, member expression, arguments 3, 3, 5, 1, 1 evaluate new, construct expa, arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or remember expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expa. Let constructor be. Get value, ref. If arguments is empty, then a let arglist be new empty list for. Else a let arglist be. Argument list evaluation of arguments. If this constructor is false, throw a type error exception. Return. Constructor, arglist. 3, 6 function calls. 3, 6, 1 runtime semantics. Evaluation. Call expression. Capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let expa be the call member expression that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let member expa be the member expression of expa. Let arguments be the arguments of expa. Let ref be. Evaluation of member expa. Let func be. Get value, ref. If ref is a reference record, is property reference, ref, is false, and ref is eval, then if same value, func, %eval %, is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return. Perform eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position, this call. Return. Evaluate call, func, ref, arguments, tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value, ref. Let this call be this call expression. Let tail call be as in tail position, this call. Return. Evaluate call, func, ref, arguments, tail call. 62. ECMA International 2024. 133, 2 evaluate call, func, ref, arguments, tail position. The abstract operation evaluate call takes arguments func, an ECMAScript language value, ref, an ECMAScript language value or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref, is true, then I let this value be get this value, ref, be else I let ref env be ref. 2. Assert, ref env is an environment record. 3. Let this value be ref env with base object, else let this value be undefined. Let arglist be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func, is false, throw a type error exception. If tail position is true, Perform prepare for tail call. Return. Call. Func. This value. Arg list. 3. 3. 7th super keyword. 3. 3. 7. 1 runtime semantics. Evaluation super property. Super. Expression. Let env be get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key. Property name value. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super property. Super. Identifier name. Let env be get this environment. Let actual this be env get this binding. Let property key be string value of identifier name. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super call. Super arguments. Let new target be get new target. Assert. New target is an object. Let func be get super constructor. Let arglist be. Argument list evaluation of arguments. If is constructor. Func is false. Throw a type error exception. Let result be. Construct. Func. Arglist. New target. Let the ser be get this environment. Perform the ser bind this value. Result. Let f be the ser. 0. Assert. F is an ECMAScript function object. 1. Perform. Initialize instance elements. Result. F2. Return result. ECMA International 2024 263 133 7. To get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called. Let envrec be get this environment. Assert. envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMAScript function object. Let superconstructor be active function. Return superconstructor. 3. 3. 7. 3 make super property reference. Actual this. Property key. Strict. The abstract operation makes super property reference takes arguments actual this. An ECMAScript language value. Property key. A property key. And strict. A boolean. And returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env be get this environment. Assert. env has super binding. Is true. Let base value be env get super base. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3, 3, 8, 1 runtime semantics, argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return list. C append next to list. Argument list. Argument list. Assignment expression. 1. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. spre, add ref, sync, repeat, let next be, iterate a step value, iterate a record, b if next is done, return preceding args, c append next to preceding args, template literal, no substitution template. Let template literal be this template literal. Let site obj be get template object, template literal. Return site obj, template literal, substitution template. Let template literal be this template literal. Let site obj be get template object, template literal. Let remaining be argument list evaluation of substitution template. Return the list concatenation of site obj and remaining substitution template. Template head expression template spans. Let first subref be evaluation of expression. Let first sub be get value, first subref. Let rest sub be substitution evaluation of template spans. Assert rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3, 9 optional chains. 3, 9 1 runtime semantics. Evaluation, optional expression, member expression optional chain. Let base reference be evaluation of member expression. Let base value be get value, base reference. If base value is either undefined or null, then a return undefined. Return chain evaluation of optional chain with arguments base value and base reference. Optional expression, call expression optional chain. Let base reference be evaluation of call expression. Let base value be get value, base reference. If base value is either undefined or null, then a return undefined. Return chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the token ECMA International 2024-265. Optional expression optional chain. Let base reference be evaluation of optional expression. Let base value be get value, base reference. If base value is either undefined or null, then a return undefined. Return chain evaluation of optional chain with arguments base value and base reference. 3, 9 2 runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return evaluate call, base value, base reference, arguments, tail call, optional chain, expression. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, base value, expression, strict, optional chain, dot. Identifier name. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict, optional chain, private identifier. Let field name string be the string value of private identifier. Return make private reference, base value, field name string, optional chain arguments. Let optional chain be optional chain. Let new reference be chain evaluation of optional chain with arguments base value and base reference. Let new value be get value, new reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain, return. Evaluate call, new value, new reference, arguments, tail call, optional chain, expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value, new reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, new value, expression, strict, optional chain, identifier name. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value, new reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, new value, identifier name, strict, 66, ECMA International 2024, optional chain, private identifier. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value, new reference. Let field name string be the string value of private identifier. Return make private reference, new value, field name string. The 3rd of March 2010 import calls. 3.3.1.0.1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let argraph be. Evaluation of assignment expression. Let specify be. Get value. Argraph. Let promise capability be. New promise capability. %promise %. Let specifier string be completion. To string. Specifier. If abrupt reject promise. Specifier string. Promise capability. Perform host load imported module. Referrer. Specifier string. Empty. Promise capability. Return promise capability. 3.3.1.0.1 continue dynamic import. Promise capability. Module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined reason be return unused. Let onRejected be create built-in function rejected closure. 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. A let link be completion module link be if link is an abrupt completion, then I perform call promise capability undefined link. 2. Return unused. C let evaluate promise B module evaluate. D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace. Module 2. Perform. Call. Promise capability. Undefined. Namespace 3. Return unused.
Plus assist. Okay, so not much happened in the stream other than planning, looking stuff up, and then planning, and then planning, and then thinking, and then whatever. So the first part of the stream, that was that. Whatever I said earlier, all that stuff. Ditto. And for now though, I'm gonna get on this other Windows install. I gotta unplug a couple cables around, and then I'm gonna get on this computer. I'm gonna get to programming maybe for 2 hours. I'm not gonna get as much done. I'm gonna not talk because I have to do something, otherwise nothing will get done. But I'm gonna be finding any missed ints, unsigned in, signed in. I didn't miss any, but there's a couple other types that I have to deal with or whatever. So instead of explaining everything, because I just have to do it. I don't know. I'm basically just gonna do whatever I did the other day. We had the long stream. I got there's probably 2% left of teeny corner cases to account for now that I'm gonna do. I gotta unplug a monitor, pull out the cable, plug in the other one. I don't want to do this. This is so annoying. I just plugged them all in. So I'm gonna have to unplug stuff again. So I'll put it, I don't know. I'll just put it on this screen. I'm gonna unplug stuff, plug it back in, and get to work, stop talking. That's fair. I don't know. I gotta get Siri reading again. Reading the standard. I think it's stuck in highlight mode now. Please don't be stuck in highlight mode. Okay, now it's working. I had some haters. I think they disappeared. my channel traffic went down. I don't know what happened. I don't know.
.4 array object.
I don't want to like validate whatever, I don't know. I was just not be the bigger person.
Value is always a non-negative integer less than 232. The value of the length property is numerically greater than the name of every property whose name is an array index. Whenever a property of an array object.
People like complain about being the bigger person. It's because you don't get it. You don't get what it really means to be the bigger person. Anyways, I'm gonna unplug these monitors and get something done other than plan, think, look stuff up, figure out, and whatever.
Properties of an array object and is unaffected.
I'm the bigger person.
Its prototypes. An object. Oh.
I'm not gonna complain about it.
Be the result of calling the for each integer I in the range of 0 to 32 len a let elim be the result of calling the internal method of a with argument to string I b if elim is undefined. Return true 3. Return 1. The array constructor called as a function. When array is called as a function rather than as a constructor, it creates and initializes a new array object. Thus, the function call array is equivalent to the object creation expression new array with the same arguments 5, 4, 1. 1 array, item 1, item 2. When the array function is called, the following steps are taken. Create and return a new array object exactly as if the standard built-in constructor array was used in a new expression with the same arguments 1, 5, 4, 2. Note, has instance defined in 1, 5, 3, 4, 5, 3. ECMA International 2009 121 1, 5, 4, 2. The array constructor. When array is called as part of a new expression, it is a constructor. It initializes the newly created object 5, 4, 2. 1 new array, item 0, item 1. This description applies if and only if the array constructor is given no arguments or at least 2 arguments. The internal property of the newly constructed object is set to the original array prototype object, the one that is the initial value of array prototype.
Okay, I think I have everything plugged in or whatever. What time is it? Ah, man. I'm not gonna explain stuff, whatever. I really need to stop saying whatever, like for real. I talked about everything earlier. I'm just gonna get this computer running, this potato computer, because it did boot. I think it's working. So I'm gonna like Siri stopped reading. Okay, that's great. I'm gonna get Siri to read the documentation or whatever. I'm gonna stop saying that word, and I'm gonna try to get the rest of those types. So I can get to the 64-bit arithmetic, and then I'll do the JavaScript like demo thingy to compare the speeds of my JavaScript engine versus, I don't know, maybe I can get like the Opera JavaScript engine and even I can't talk, Internet Explorer 2 or something. Like get a wrapper for them in C so I can compare. I think they all basically use the same thing. None of that matters. I'll do that too in a couple days and I'll work out towards getting it done. So for now, I'm gonna stop talking and place types and stuff. Whatever I've been doing the last freaking week or so. Kind of. I think there's other stuff, like organizing files and I don't know. So I'm gonna do that right now and stop talking.
environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1: programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2: the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock. Then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster: candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents. When per agent resource accounting indicates that the agent is runaway. Note 6: all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7: an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9: forward progress. For an agent to make forward progresses for it to perform an evaluation step according to this specification, an agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, One agent eventually makes forward progress. ECMA International 2024 163, an agent does not cause another agent to become blocked except via explicit APIs that provide blocking. 0.10 Processing model of weak ref and finalization registry targets 9.10. 1 Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype deriv is called, the referent, if undefined is not returned, is kept alive so that subsequent, synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made, after synchronous ECMAScript execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref deriv of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sexcst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024, there exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note for the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, Do a for each week ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG ls contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each week map such that map contains a record R such that R value. Do I set R to set R to empty. D for each week set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, finalization registry, the host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, JavaScript schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12. Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry hasn't internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear-kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called autotype. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O1 0, 1, 1. 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O1 0, 1, 2. V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary set prototype of O. V1 0, 1, 2. 1 ordinary set prototype of O. V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, V, current, is true, return true. Let extensible be O if extensible is false, return false. Let bev, let done be false, repeat. While done is false, A if P is null, then I set done to true. B else if same value, P, O, is true, then I return false. C else, I if P is not the ordinary object internal method defined in 1 0, 1, 1. Set done to true. 2. Else, set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for int 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. O1 0, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return O1 0, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. O1 0, 1, 4. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property, O, P1 0, 1, 5. 1 ordinary get own property, O, P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6. P. Desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define known property, O, P, desk 1 0, 1, 6. 1 ordinary define known property, O, P, desk. The abstract operation ordinary define known property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O, P, let extensible be, is extensible, O, return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1, 0, 1, 6, 3, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current. The abstract operation, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert, is property key, P, is true if current is undefined. Then, if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desk, is true. Then, I create an own accessor property named P of object O whose, and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose, and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value, otherwise you return true. Assert, current is a fully populated property descriptor. If desk does not have any fields, return true. If current is false, then 70. ECMA International 2024. ABC. If desk has a field and desk is true, return false. If desk has an field and desk is not current, return false. If is generic descriptor, desk, is false and is accessor descriptor, desk, is not is accessor descriptor, current, return false. D if is accessor descriptor, current, is true, then I if desk has a current, return false. 2. If desk has a current, else if current is false, then I if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then if is data descriptor, current is true and is accessor descriptor, desk is true. Then if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor, current is true and is data descriptor, desk is true. Then if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. C else, for each field of desk, set the corresponding attribute of the property named P of object O to the value of the field 7. Return true 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7. 1. Ordinary has property O, P. The abstract operation ordinary has property takes argument so, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, P. If his own is not undefined, return true. Let parent be O. If parent is not null, then a return parent. P5. Return false 0, 1, 8. The following steps when called. Return. Ordinary get O, P. Receiver ECMA International 2024 171 10 1 8 1. Ordinary get O, P. Receiver. The abstract operation ordinary get takes argument so, an object, P, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then a let parent be O, B. If parent is null, return undefined. C. Return parent. If is data descriptor, desk, is true, return desk. Assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return. Call, getter, receiver 0, 1, 9. The return. Ordinary set O, P, V. Receiver 1, 0, 1, 9. 1. Ordinary set O, P, V. Receiver. The abstract operation ordinary set takes argument so, an object, P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be O, P. Return. Ordinary set with own descriptor O, P, V. Receiver, own desk 0, 1, 9. 2. Ordinary set with own descriptor O, P, V. Receiver, own desk. The abstract operation ordinary set with own descriptor takes argument so, an object, P, a property key, V, an ECMAScript language value, receiver, an ECMAScript language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be O, B. If parent is not null, then I return parent. I set own desk to the property descriptor, undefined, true, true, true. If is data descriptor, own desk, is true. Then, 72. ECMA International 2024. ABCDE. If ownDesk is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver P. If existing descriptor is not undefined, then if is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let valueDesk be the property descriptor, v. I've return receiver P valueDesk, else I assert receiver does not currently have a property P. 2. Return create data property receiver P v assert is accessor descriptor ownDesk is true. Let setter be ownDesk. If setter is undefined, return false. Perform call setter receiver v return true. 0 1 1 0 P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary delete O P10 1 1 0 1 ordinary delete O P. The abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be O P. If desk is undefined, return true. If desk is true, then A remove the own property with name P from O. B return true. Return false. 0 1 1 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys O10 1 1 1 1 ordinary own property keys O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys. 5. Return keys 0 1 1 2 ordinary object create proto additional internal slots list. The abstract operation ordinary object create takes argument proto an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object internal slots list. Set O to proto return O 0 1 1 3 ordinary create from constructor intrinsic default PR auto internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto as used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be Get prototype from constructor. Constructor, intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be new empty list. Return ordinary object create. Proto, slots list. 0, 1, 1 4 get prototype from constructor. Constructor, intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for.
So, I don't know. I ran the compiler. I'm gonna run the program. I'll compare the output. It should work. I didn't change anything yet. And then, I'm gonna save it back up and probably like, I'm not gonna get much done today, like an hour. I'm gonna like find and replace and try to clean up and find some of the last couple types or whatever and tag them and build it and stuff. I don't know. Tomorrow, if I can get all this done in an hour, put in the addresses and stuff, and download some programs for the OpenGL that stuff. So I'm gonna do that.
January 2015 require internal slot. Oh, internal slot. The abstract operation require internal slot take S argument so, an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript function objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of the code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript function object may be either strict mode code, 1122, or non-strict code. An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to and ECMAScript function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMAScript code. A parse node. The root parse node of the source text that defines the function's body. Construct kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode, lexical, strict, or global, defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30, internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. str. Iced. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name. A string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If f is true, then a let error be a newly created type error object. B note. Error is created in callee context with f's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0, 2, 1, 1 prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMAScript function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMAScript code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note. Any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. 2 ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMAScript function object, callee context, an execution context, and this argument, an ECMAScript language value, and returns unused. It performs the following steps when called. Let this mode be F. If this mode is lexical, return unused. Let callee realm be F. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert. Global env is a global environment record. 3. Let this value be global env be else I let this value be. To object, this argument 2. Note, to object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value 0. Return unused 0, 2, 1. 3. Runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Function body. Function statement list. Return. Evaluate function body of function body with arguments function object and arguments list. Concise body. Expression body. Return. Evaluate concise body of concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body. Function body. Return. Evaluate generator body of generator body with arguments function object and arguments list. Async generator body. Function body. Return. Evaluate async generator body of async generator body with arguments function object and arguments list. Async functio and body. Function body. Return. Evaluate async function body of async function body with arguments function object and arguments list. Async concise body. Expression body. Return. Evaluate async concise body of async concise body with arguments function object and arguments list. Initializer. Assignment expression. Assert. Arguments list is empty. Assert. Function object is not empty. If is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object. Else a let RHS be. Evaluation of assignment expression be let value be. Get value, RHS. Return completion record. Return value. Empty. Class static block body. Class static block statement list. Assert. Arguments list is empty. Return. Evaluate class static block body of class static block body with argument function object. 0, 2, 1. For ordinary call evaluate body. F. Arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMAScript function object F takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F if kind is base, then let this argument be. Ordinary create from constructor. New target. %object prototype %4. Let callee context be prepare for ordinary call. F. New target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, B let initialize result be completion, initialize instance elements. This argument, F. See if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result lu is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0. 2. 3. Ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMAScript function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 10. 2. 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set f to strict. If this mode is lexical this, set f to lexical. 0. Else if strict is true, set f to strict. 1. Else, set f to global. 2. Set f to false. 3. Set f to env. 4. Set f to private env. 5. Set f to get active script or module. 6. Set f to the current realm record. 7. Set f to undefined. 8. Set f to a new empty list. 9. Set f to a new empty list. 0. Set f to empty. 1. Let len be the expected argument counter parameter list. 2. Perform set function length. F. Len. 3. Return F. ECMA International 2024 179. 10. 2. 4. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. F. Realm. The abstract operation. Capital A. D. D. Capital R. E. S. T. R. I. C. T. E. D. Capital F. U. N. C. T. I. O. N. Capital P. R. O. P. E. R. T. I. E. Takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. E. Numerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor. F. Writable prototype. Prototype. The abstract operation make constructor takes argument f, an ECMAScript function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then A assert is constructor, f is false. B assert f is an extensible object that does not have a prototype own property. C set f to the definition specified in 10, 2, else A set f to the definition specified in 10, 3, 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then A set prototype to ordinary object create. %object prototype %. B perform. Define property or throw prototype. Constructor. Property descriptor. F. Writable prototype. False. True. Perform. Define property or throw F. Prototype. Property descriptor. Prototype. Writable prototype. False. False. Return unused. 80. ECMA International 2024. 102. 6. Make class constructor. F. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert f is false. Set f to true. Return unused. 0, 2, 7. Make method. F. Home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object. Return unused. 0, 2, 8. Define method property. Home object. Key. Closure. Enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else, a let desk be the property descriptor. Closure. True. Enumerable. True. B perform. Define property or throw. Home object. Key. Desk. C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9. Set function name. F. Name. Prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name, then A set name to name. If f has an internal slot, then A set f to name. If prefix is present, then A set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f. name, property descriptor, name, false, enumerable, false, true, return unused. ECMA International 2024 181, the 10th of February 2010. Set function length, f, length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw. F. Length. Property descriptor. Length. False. Enumerable. False. True. Return unused. 0, 2, 1, 1. Capital F. U. N. C. T. I. O. N. Capital D. E. C. L. A. R. A. T. I. O. N. Capital I. N. S. T. A. N. T. I. A. T. I. Func. Arguments list. The abstract operation. Capital F. U. N. C. T. I. O. N. Capital D. E. C. L. A. R. A. T. I. O. N. Capital I. N. S. T. A. N. T. I. A. T. I. Takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a for binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then note, arrow functions never have an arguments object. Be set arguments object needed to false. 7. Else if parameter names contains arguments, Then, a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false. Then, if function names contains arguments or lexical names contains arguments. Then, I set arguments object needed to false. 9. If strict is true or has parameter expressions is false. Then, a note, only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval, let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. Let callee env be the lexical environment of callee context. Let env be new declarative environment. Callee env. Deassert. The variable environment of callee context is callee env. Set the lexical environment of callee context to env1. For each string param name of parameter names, do a let already declared env has binding. Param name, note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding. Param name, undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create and mapped arguments object, arguments list. Else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true. Then, I perform env create immutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. Else, I perform env create mutable binding, arguments, false. Perform env initialize binding, arguments. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then I perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else, I perform iterator binding initialization of formals with arguments iterator record and env27. If his parameter expressions is false, then, a note, only a single environment record is needed for the parameters and top-level vars. Let instantiated var names be a copy of the list parameter bindings. See for each element n of var names. Do I have instantiated var names does not contain n. Then, append n to instantiated var names. Perform env create mutable binding. N. False. Perform env initialize binding. N. Undefined. Let var env be env28. Else, a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. Let var env be new declarative environment. env. C set the variable environment of callee context to var env. Let instantiated var names be a new empty list. For each element n of var names. Do I have instantiated var names does not contain n. Then, ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding. N. False. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined 4. Else, a let initial value be env get binding value. N. False. Perform var env initialize binding. N. Initial value. Note. A var with t, his same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note. An xb. 3. 2. 1 adds additional steps at this point. 0. If strict is false, then a let lexi env be new declarative environment. Var env be note. Non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexenv be var-env. 2. Set the lexical environment of callee context to lexenv. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element D of lex declarations, do a note. A lexically declared name cannot be the same as a function-generated declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D. Do I if this constant declaration of D is true, then perform lexenv create immutable binding. Dn true 2. Else perform lexenv create mutable binding. Dn false 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexenv and private env. C perform var-env set mutable binding. Fn fo false 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1, 0, 3, 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1, 0, 3, 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign. ECMA International 2024 1031. This argument, argum NTS list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f. This argument, arguments list, undefined 1, 0, 3, 2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, arguments list, new target 1, 0, 3, 3 built-in call or construct, f. This argument, arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, a new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation. Defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record, that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides the this value arguments list, provides the named parameters new target, provides the new target value. 1. Note: if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or rather means. 2. Remove callee context from the execution context stack and restore callee context as the running execution context. 3. Return result. 0. 3. 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional argument, ts realm, a realm record, prototype, an object or null, and prefix, a string, and returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185. Be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0. 4. 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, Internal slots of bound function exotic objects. Internal slot type description. Bound target function a callable object. The wrapped function object. Bound this an ECMAScript language value. The value that is always passed is this value when calling the wrapped function. Bound arguments a list of ECMAScript language values. A list of values whose elements are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 10411. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f. Let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct. Target. Args. New target. 0, 4, 1. 3 bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMAScript language value. And bound args. A list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 10411. If this constructor, target function, is true, then a set obj as described in 10412. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1. P, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desk. Else if P is an array index, then a let length desk be ordinary get own property, A, length, B assert, is data descriptor, length desk, is true, C assert, length desk is false, D let length be length desk, E assert, length is a non-negative integral number, F let index be, tune 32, P, G if index length and length desk is false, return false, H let succeeded B. Ordinary define own property, A, P, desk, I have succeeded is false, return false, J if index length, then I set length desk to index plus 1, 2. Set succeeded to. Ordinary define own property, A, length, length desk, 3. Assert, succeeded is true, K return true, return. Ordinary define own property, A, P, desk, 0, 4, 2. To array create, length, proto, the abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let A be make basic object. Set A to proto. Set A is specified in 1 0 4 2 1. Perform. Ordin array define own property A, length, property descriptor, length true, false, false. Return A 0 4 2 3 array species create. Original array, length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be. Is array, original array. If is array is false, return. Array create, length. Let C be. Get, original array, constructor. If is constructor, C, is true, then 88. ECMA International 2024. A let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then I have same value. C. Realm is true. Set C to undefined. If C is an object, then I set C to get C. Add at species. B if C is null, set C to undefined. If C is undefined, return. Array create, length. If is constructor, C, is false, throw a type error exception. Return. Construct, C, length, 0, 4, 2, 4 array set length, A, desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define own property, A, length, desk. Let new len desk be a copy of desk. Let new len be. Tune 32, desk. Let number len be. To number, desk. If same value 0, new len, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property, A, length. Assert, is data descriptor. Old len desk, is true. Assert, old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define own property, A, length, new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else, a note, setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be. Ordinary define own property, A, length, new len desk. 6. If succeeded is false, return false. 7. For each shown property, key P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded B. A P B if delete succeeded is false. Then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define known property A length new len desk I've return false. 8. If new writable is false, then assert succeeded to ordinary define known property A length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property S P. If desk is not undefined, return desk. Return string get own property S P 0, 4, 3, 2 P desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property S P. If string desk is not undefined, then a let extensible be S. P return is compatible property descriptor extensible desk string desk return ordinary define known property S P desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O assert str is a string. Let len be the length of str for each integer I such that 0 len in ascending order. Do a append to string I to keys for each shown property key P of O such that P is an array index and to an integer or infinity P len in ascending numeric index order. Do a append P to keys for each shown property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024 8. For each shown property key P of O such that P is a symbol, in ascending chronological order of property creation, do a append P to keys. 9. Return keys 0, 4, 3, 4 string create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5. String get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r. Index plus 1, 1. Return the property descriptor. Result str. False. True. False. 0. 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2, 0, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note 5. ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor. 0, 4, 4, 1. P. The internal method of an arguments exotic object args takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, args, p. If desk is undefined, return undefined. Let map be args, let is mapped be. Has own property, map, p. If is mapped is true, then a set desk to get map p6. Return desk 0, 4, 4, 2, p. Desk, the internal method of an argument's exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, p. Let new arg desk be desk. If is mapped is true and is data descriptor, desk, is true. Then, if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map p. Let allowed be ordinary define own property args p. New arg desk 92 ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor desk is true, then I perform map p. Be else if desk has a field, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p. Desk false 2. If desk has a field and desk is false, then perform map p8. Return true 0, 4, 4, 3. The let map be args, let is mapped be. Has own property, map p. If is mapped is false, then a return ordinary get args p. Receiver 4. Else a assert map contains a formal parameter mapping for p. P return get map p 0, 4, 4, 4. The if same value args receiver is false, then a let is mapped be false. Else a let map be args b let is mapped be. Has own property map p. If is mapped is true, then a assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, b perform set map p. V. False. Return ordinary set args p. V. Receiver 0, 4, 4, 5, p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map p. Let result be ordinary delete args p. If result is true and is mapped is true, then a perform map p5. Return result ECMA International 2024 193 104 4 6. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create %object prototype set obj to undefined. Perform define property or throw obj length property descriptor len true enumerable false true. Let index be 0. Repeat while index len a let val be arguments list index be perform create data property or throw obj to string index val c set index to index +1. Perform define property or throw obj add iterator property descriptor %array prototype values true false true. Perform define property or throw obj callee property descriptor %throw type error false false. Return obj 0, 4, 4, 7. Create mapped arguments object func formals arguments list env The abstract operation create map arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0, 4, 4, 1. Set obj is specified in 1 0, 4, 4, 2. Set obj is specified in 1 0, 4, 4, 5. Set obj to percent object prototype percent 0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While int x len let val be arguments list. Index be perform. Create data property or throw obj to string int x val c set index plus 1 6. Perform. Define property or throw obj length property descriptor len true e false true 7. Let map names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0 94. ECMA International 2024 ABC. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If int x len, then let g be make arg getter name env. Let p be make arg setter name env. Perform map to string int x property descriptor get g false true set index 1 20. Perform. Define property or throw obj at iterator property descriptor percent array prototype values percent true false true 1. Perform. Define property or throw obj callee property descriptor func true false true 2. Return obj 0 4 4 7 1 make arg getter name env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value name false. Let getter be create built-in function getClosure 0. Note: getter is never directly accessible to ECMAScript code. Return getter 0 4 4 7 to make arg setter name env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters value that captures name and env and performs the following steps when called. A return env set mutable binding name value false. Let setter be create built-in function setClosure 1. Note: setter is never directly accessible to ECMAScript code. Return setter 0 4 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0 4 5 1 p. The internal met pod of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor value true, true, true. Return ordinary get own property. O. P. ECMA International 2024 195 10452. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Return as valid integer index. O. Numeric index. Return. Ordinary has property O. P 0 4 5 3 P desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if as valid integer index O. Numeric index is false. Return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If as accessor descriptor desk is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform typed array set element. Oh, numeric index desk 7. Return true. Return ordinary define known property O. P desk 0 4 5 4. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I return typed array get element. Oh, numeric index 2. Return ordinary get O. P receiver 0 4 5 5. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric ind x is not undefined. Then I have same value O. Receiver is true. Then perform typed array set element. Oh, numeric int x v return true. 2. If as valid integer index O. Numeric int x is false, return true. Return ordinary set O. P v receiver 96. ECMA International 2024 10456. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if as valid integer index O. Numeric int x is false, return true, else return false. 2. Return ordinary delete O. P 0 4 5 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST. Let keys be a new empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record b for each integer I such that 0 length. In ascending order, do I append to string I to keys for each own property key p of O such that p is a string and p is not an integer index. In ascending chronological order of property creation, do I append p to keys for each own property key p of O such that p is a symbol. In ascending chronological order of property creation, do I append p to keys 6. Return keys 0, 4, 5, 8 typed array with buffer witness records, and typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, B, J, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexcst or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj if is detached buffer is true. Then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. Obj, byte length, 5.10 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length. Tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size 0, 4, 5, 1, 2 typed array length. Tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert. Is typed array out of bounds. Tar record. Is false. Let O be tar record. If O is not auto, return O. Assert. Is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert. byte length is not detached. Return floor, byte length, byte offset, element size 0, 4, 5, 1, 3 is typed array, out of bounds. tar record. The abstract operation is typed array, out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer. O. Is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O if O is auto. Then, a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O, be let byte offset end be byte e offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments O, a typed array, and an x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, int x, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If R, int x, 0 or R, int x, length, return false. Return true. 0, 4, 5, 1, 5 typed array get element. O. Index. The abstract operation typed array get element takes arguments O, a typed array, and an x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index, O, int x, is false, return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be R, int x, element size plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer. Element type. True. Unordered. 0, 4, 5, 1, 6 typed array set element. O. Int x. Value. The abstract operation typed array set element takes arguments O, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To big int, value. Otherwise, let num value be. To number, value. If is valid integer index, O, int x, is true, then a let offset be O, be let element size be typed array element size. O, see let byte index in buffer be R, int x, element size plus offset. D let element type be typed array element type. O, E perform set value in buffer. O, byte index in buffer. Element type, num value. True, unordered, return unused. ECMA International 2024 199, 10, 4, 5, 1, 7 is array buffer view out of bounds. O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be make data view with buffer widths s record. O sexy st b return is view out of bounds view record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy st return is typed array out of bounds tar record 0 4 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module C16 2 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare f and 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V. 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain p, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6 p. Desk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is accessor descriptor, desk, is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk, current, return true, 0, 4, 6, 7, p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a symbol, return. Ordinary has property O, p. Let exports be O. If exports contains p, return true, return false. ECMA International 2024 201 10 4 6 8. The if p is a symbol, then a return. Ordinary get O, p. Receiver let exports be O. If exports does not contain p, return undefined. Let m be O. Let binding be m. Resolve export p. Assert binding is a resolved binding record. Let target module be binding. Assert target module is not undefined. If binding is namespace, then a return get module namespace target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception 2. Return target env jet binding value binding true 0, 4, 6, 9. The return false 1, 0, 4, 6, 1, 0. P. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a symbol, then a return. Ordinary delete O, p. Let exports be O. If exports contains p, return false. Return true 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 10 4 6 1 2 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let m be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 1 0 4 6. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype. Sort % using undefined as compare f and set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7. 1. V. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O v1 0 4 7 2 set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value v current is true. Return true, return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see Table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. Proxy handler methods. Internal methods. Handler methods. Get prototype of set prototype of is extensible. Prevent extensions. Get own property descriptor. Define own property has get set delete property own keys call apply construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object. P is a property key value. V is any ECMAScript language value and desc is a property descriptor record. O for copyright sign. ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible. Target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined. Then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false. Return false. Let extensible target be. Is extensible. Target 0. If extensible target is true, return true 1. Let target prota be target 2. If same value, v, target prota, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of type of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. Let target result be is extensible. Target. If boolean trap result is not target result, throw a type error exception 0. Return boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. If boolean trap result is true, then a let extensible target be is extensible. Target b. If extensible target is true, throw a type error exception. Return boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy. O. Dot. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result obj be. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target. P. 0. If trap result obj is undefined, then A. If target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target 2. Let result desk be to property descriptor trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desk. The internal method of a proxy exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desk. Let desk obj be from property descriptor. Desk. Let bow boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desk obj. If boolean trap result is false, return false. 0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desk is undefined, then if extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 5. Else if is compatible property descriptor, extensible target, desk, target desk, is false, throw a type error exception. B. If setting config false is true and target desk is true, throw a type error exception. C. If is data descriptor, target desk, is true, target desk is false, and target desk is true, then I. If desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desk be target. P. B. If target desk is not undefined, then I. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. Return boolean trap result 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor. Target desk is true and target desk is false, then if same value. Trap result. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true and target desk 0. Return trap result. Note: the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable, non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor. Target desk is true and target desk is false, then if same value. V. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true, then if target desk 1. Return true. Note: X enforces the following invariance. The result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. If Boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note: for proxy objects enforces the following invariance. The result of is a Boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call trap handler target. Let trap result be. Create list from array like trap result array string symbol. If trap result contains any duplicate entries, throw a type error exception 0. Let extensible target be. Is extensible target 1. Let target keys be target 2. Assert target keys is a list of property keys 3. Assert target keys contains no duplicate entries 4. Let target configurable keys be a new empty list 5. Let target non-configurable keys be a new empty list 6. For each element key of target keys, do a let desc be target key be if desc is not undefined and desc is false. Then I append key to target non-configurable keys c else I append key to target configurable keys 7. If extensible target is true and target non-configurable keys is empty, then a return trap result 8. Let unchecked result keys be a list whose elements are the elements of trap result 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception be remove key from unchecked result keys 0. If extensible target is true, return trap result 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception be remove key from unchecked result keys 2. If unchecked result keys is not empty, throw a type error exception 3. Return trap result. Note for proxy objects enforces the following invariants. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. Array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Capital C. Construct. Target. Arguments list. New target. Let array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target, handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let p be make basic object. Set p's essential internal methods, except for and, to the definitions specified in 10.5. If is callable, target, is true, then a set p is specified in the 10th of May 2012. B if is constructor, target, is true, then I set p is specified in the 10th of May 2013. Set p to target, set p to handler, return p, 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U+0000 to U+10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequencer as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U+000a is line feed, LF. And therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000a occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000a to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0XFF, return the string value consisting of the code unit whose numeric value is CP. Let K1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let Q2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 XDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics, code points to string, Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1, 1, 3 static semantics, UTF-16 surrogate pair to code point, led, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0xD800. 0 times 400 plus trail 0xDC00 plus 0 times 10,000. Return the code point CP 1, 1. 4 static semantics. Cod point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1, 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string, position. Be append CP to code points. Set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note 2, see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, C10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text. The 7th of March 2026 private element find. O. P. The abstract operation private element find takes arguments O, an object, and P, a private name, and returns a private element or empty. It performs the following steps when called. If O contains a private element pay such that pay return empty, 3.27 private field add. O. P. Value. The abstract operation private field add takes arguments O, an object, P, a private name, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If the host is a web browser, then a perform. Host ensure can add private element. O. Let entry be private element find. O. P. If entry is not empty, throw a type error exception. Append private element. Field. Value. To O. Return unused. 3.28 private method or accessor add. O. Method. The abstract operation private method or accessor add takes arguments O, an object, and method, a private element, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Method is either method or accessor. If the host is a web browser, then a perform. Host ensure can add private element. O. Let entry be private element find. O. Method. If entry is not empty, throw a type error exception. Append method to O. Return unused. 3.29 host ensure can add private element. O. The host-defined abstract operation host ensure can add private element takes argument O, an object, and returns either a normal completion containing unused or a throw completion. It allows host environments to prevent the addition of private elements to particular host-defined exotic objects. An implementation of host ensure can add private element must conform to the following requirements. If O is not a host-defined exotic object, this abstract operation must return normal completion, unused, and perform no other steps. Any two calls of this abstract operation with the same argument must return the same kind of completion record. The default implementation of host ensure can add private element is to return normal completion, unused. This abstract operation is only invoked by ECMAScript hosts that are web browsers. Note the values for private methods and accessors are shared across instances. This operation does not create a new copy of the method or accessor. 4. Copyright sign. ECMA International 2024. The 7th of March 1930 private get. O. P. The abstract operation private get takes arguments O, an object, and P, a private name, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let entry be private element find O. P. If entry is empty, throw a type error exception. If entry is either field or method, then a return entry. Assert entry is accessor. If entry, let getter be entry. Return call getter O, 3.31 private set O. P. Value. The abstract operation private set takes arguments O, an object, P, a private name, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let entry be private element find O. P. If entry is empty, throw a type error exception. If entry is field, then a set entry to value. Else if entry is method, then A throw a type error exception. Else A assert entry is accessor. B if entry, C let setter be entry. D perform call setter O. Value. Return unused, 3.32 define field. Receiver. Field record. The abstract operation define field takes arguments receiver, an object, and field record, a class field definition record, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let field name be field record. Let initializer be field record. If initializer is not empty, then a let init value be. Call initializer receiver for. Else a let init value be undefined. If field name is a private name, then a perform private field add receiver field name init value. Else a assert is property key field name is true. B perform create data property or throw receiver field name init value. Return unused. ECMA International 2024-85. The 7th of March 1933. Initialize instance elements. O. Constructor. The abstract operation initialize instance elements takes arguments O, an object, and constructor, an ECMAScript function object, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let methods be the value of constructor. For each private element method of methods, do a perform private method or accessor add O. Method. Let fields be the value of constructor. For each element field record of fields, do a perform define field O. Field record 5. Return unused, 3.34 add value to keyed group. Groups. Key. Value. The abstract operation add value to keyed group takes arguments groups, a list of records with fields, a list of ECMAScript language values, key, an ECMAScript language value, and value, an ECMAScript language value, and returns unused. It performs the following steps when called. For each record, G of groups, do A if same value, G, I assert, exactly one element of groups meets this criterion. 2. Append value to G. 3. Return unused. Let group be the record. Value. Append group to groups. Return unused, 3.35 group by. Items. Callback and key coercion. The abstract operation group by takes arguments items, an ECMAScript language value, callback and an ECMAScript language value, and key coercion, property or 0. And returns either a normal completion containing a list of records with fields, a list of ECMAScript language values, or a throw completion. It performs the following steps when called. Perform. Require object coercible. Items if is callable. Callback and is false. Throw a type error exception. Let groups be a new empty list. Let iterator record be. Get iterator. Items. Sync. Let 0 repeat. 6. ECMA International 2024. A, B, C, D, E, F, G, H. If K253 1, then I let error be throw completion, a newly created type error object. 2. Return. Iterator close. Iterator record. Error. Let next be. Iterator step value. Iterator record. If next is done, Then I return groups. Let value be next. Let key be completion. Call callback fin undefined value k. If abrupt close iterator key iterator record. If key coercion is property, then I set key to completion to property key 2. If abrupt close iterator key iterator record. Else I 2 assert key coercion is 0. If key is -0, set key to +0. I perform add value to keyed groups key value j set k to k plus 1.4 operations on iterator objects. See common iteration interfaces 27.1, 4.1 iterator records. An iterator record is a record value used to encapsulate an iterator or async iterator along with the next method. Iterator records have the fields listed in Table 15. Table 15. Iterator record fields. Field name, value, meaning, iterator, an object that conforms to the iterator or async iterator interface. Next method, an ECMAScript language value, the next method of the object. Done, a boolean, whether the iterator has been closed. 7. 4. To get iterator from method, obj, method. The abstract operation getIterator from method takes arguments obj, an ECMAScript language value, and method, a function object, and returns either a normal completion containing an iterator record or a throw completion. It performs the following steps when called. Let iterator be. Call method obj. If iterator is not an object, throw a type error exception. Let next method be get iterator. Next, let iterator record be the iterator record. Iterator. Next method. False. Return iterator record, 4.3 get iterator. Obj. Kind. The abstract operation get iterator takes arguments obj, an ECMAScript language value, and kind, sync or async, and returns either a normal completion containing an iterator record or a throw completion. It performs the following steps when called. If kind is async, then a let method be get method obj at async iterator. B if method is undefined, then I let sync method be get method obj at iterator. 2. If sync method is undefined, throw a type error exception. 3. Let sync iterator record be get iterator from method obj sync method. 5. Return create a sync from sync iterator record. Else a let method be get method obj at iterator. If method is undefined, throw a type error exception. Return get iterator from method obj method. ECMA International 2024-87. 7. 4. For iterator next iterator record value. The abstract operation iterator next takes argument iterator record, an iterator record, and optional argument value, an ECMAScript language value, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. If value is not present, then a let result be call iterator record, else a let result be call iterator record, value. If result is not an object, throw a type error exception. Return result, 4.5 iterator complete. Iter result. The abstract operation iterator complete takes argument iter result, an object, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return to boolean. Get iter result. Done, 4.6 iterator value. Iter result. The abstract operation iterator value takes argument iter result, an object, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. 1. Return get iter result value, 4.7 iterator step, iterator record. The abstract operation iterator step takes argument iterator record, an iterator record, and returns either a normal completion containing either an object or false, or a throw completion. It requests the next value from iterator record by calling iterator record and returns either false indicating that the iterator has reached its end or the iterator result object if a next value is available. It performs the following steps when called. Let result be. Iterator next. Iterator record. Let done be. Iterator complete. Result. If done is true, return false. Return result, 4.8 iterator step value. Iterator record. The abstract operation iterator step value takes argument iterator record, an iterator record, and returns either a normal completion containing either an ECMAScript language value or done, or a throw completion. It requests the next value from iterator record by calling iterator record and returns either done indicating that the iterator has reached its end or the value from the iterator result object if a next value is available. It performs the following steps when called. Let result be C. Completion. Iterator next. Iterator record. If result is a throw completion, then A. Set iterator record to true. B. Return result. Set result to result. Let done be completion. Iterator complete. Result. If done is a throw completion, then A. Set iterator record to true. B. Return done. Set done to done. 8. ECMA International 2024. 7. If done is true, then A. Set iterator record to true. B. Return done. Let value be completion. Get. Result. Value. If value is a throw completion, then A. Set iterator record to true 10. Return value, 4.9 iterator close. Iterator record. Completion. The abstract operation iterator close takes arguments iterator record, an iterator record, and completion, a completion record, and returns a completion record. It is used to notify an iterator that it should perform any actions it would normally perform when it has reached its completed state. It performs the following steps when called. Assert. Iterator record is an object. Let iterator be iterator record. Let inner result be completion. Get method. Iterator. Return. If inner result is a normal completion, then a let return be inner result. B if return is undefined. Return completion. C set inner result to completion. Call. Return. Iterator. If completion is a throw completion, return completion. If inner result is a throw completion, return inner result. If inner result is not an object, throw a type error exception. Return completion, 4.10 if abrupt close iterator. Value. Iterator record. If abrupt close iterator is a shorthand for a sequence of algorithm steps that use an iterator record. An algorithm step of the form. If abrupt close iterator. Value. Iterator record means the same thing as assert. Value is a completion record. If value is an abrupt completion, return. Iterator close. Iterator record. Value else. Set value to value, 4.11 async iterator close. Iterator record. Completion. The abstract operation async iterator close takes arguments iterator record, an iterator record, and completion, a completion record, and returns a completion record. It is used to notify an async iterator that it should perform any actions it would normally perform when it has reached its completed state. It performs the following steps when called. Assert. Iterator record is an object. Let iterator be iterator record. Let inner result be completion. Get method. Iterator. Return. If inner result is a normal completion, then a let return be inner result. B if return is undefined. Return completion. C set inner result to completion. Call. Return. Iterator. D if inner result is a normal completion, set inner result to completion. Await. Inner result. If completion is a throw completion, return completion. If inner result is a T, here completion, return inner result. If inner result is not an object, throw a type error exception. Return completion. ECMA International 2024-89. The 7th of April 2012. Create item result object. Value. Done. The abstract operation create item result object takes arguments value, an ECMAScript language value, and a boolean, and returns an object that conforms to the iterator result interface. It creates an object that conforms to the iterator result interface. It performs the following steps when called. Let obj be ordinary object create, %object prototype %perform. Create data property or throw, obj, value perform. Create data property or throw, obj, done. Return obj, 4.13 create list iterator record. List. The abstract operation create list iterator record takes argument list, a list of ECMAScript language values, and returns an iterator record. It creates an iterator, 27112, object record whose next method returns the successive elements of list. It performs the following steps when called. Let closure be a new abstract closure with no parameters that captures list and performs the following steps when called. For each element of list, do I perform. Generate a yield. Create I to result object, E, false. B return normal completion, undefined. Let iterator be create iterator from closure, closure, empty, %iterator prototype %. Return the iterator record. Iterator, generate a function prototype next %, false. Note the list iterator object is never directly accessible to ECMAScript code. 4.14 iterator to list. Iterator record. The abstract operation iterator to list takes argument iterator record, an iterator record, and returns either a normal completion containing a list of ECMAScript language values or a throw completion. It performs the following steps when called. Let values be a new empty list 2. Repeat. Let next be. Iterator step value. Iterator record. B if next is done, then I return values. C append next to values. Syntax directed operations. In addition to those defined in this section, specialized syntax directed operations are defined throughout this specification. Point 1 Runtime semantics. Evaluation. The syntax-directed operation evaluation takes no arguments and returns a completion record. Note the definitions for this operation are distributed over the ECMAScript language sections of this specification. Each definition appears after the defining occurrence of the relevant productions. 0. Copyright sign. ECMA International 2024. 8.2 Scope analysis. 2.1 Static semantics. Bound names. The syntax-directed operation bound names takes no arguments and returns a list of strings. Note default is used within this specification as a synthetic name for a module's default export when it does not have another name. An entry in the modules is created with that name and holds the corresponding value, and resolving the export named default by calling resolve export. Export name, resolve set. For the module will return a resolved binding record whose is default, which will then resolve in the modules to the above-mentioned value. This is done only for ease of specification, so that anonymous default exports can be resolved like any other export. This default string is never accessible to ECMAScript code or to the module linking algorithm. It is defined piecewise over the following productions. Binding identifier. Identifier. Return a list whose sole element is the string value of identifier. Binding identifier. Yield 1. Return yield. Binding identifier. Await 1. Return await. Lexical declaration. Let or const binding list. 1. Return the bound names of binding list. Binding list. Binding list. Lexical binding. Let names 1 be the bound names of binding list. Let names 2 be the bound names of lexical binding. Return the list concatenation of names 1 and names 2. Lexical binding. Binding identifier initializer opt 1. Return the bound names of binding identifier. Lexical binding. Binding pattern initializer. Return the bound names of binding pattern. Variable declaration list. Variable declaration list. Variable declaration. Let names 1 be bound names of variable declaration list. Let names 2 be bound names of variable declaration. Return the list concatenation of names 1 and names 2. Variable declaration. Binding identifier initializer opt 1. Return the bound names of binding identifier. ECMA International 2024-91. Variable declaration. Binding pattern initializer 1. Return the bound names of binding pattern. Object binding pattern. 1. Return a new empty list. Object binding pattern. Binding property list. Binding rest property. Let names 1 be bound names of binding property list. Let names 2 be bound names of binding rest property. Return the list concatenation of names 1 and names 2. Array binding pattern. ELIGE 1. Return a new empty list. Array binding pattern. ELIGE binding rest element. 1. Return the bound names of binding rest element. Array binding pattern. Binding element list. ELIGE 1. Return the bound names of binding element list. Array binding pattern. Binding element list. Eligible binding rest element. Let names 1 be bound names of binding element list. Let names 2 be bound names of binding rest element. Return the list concatenation of names 1 and names 2. Binding property list. Binding property list. Binding property. Let names 1 be bound names of binding property list. Let names 2 be bound names of binding property. Return the list concatenation of names 1 and names 2. Binding element list. Binding element list. Binding elision element. Let names 1 be bound names of binding element list. Let names 2 be bound names of binding elision element. Return the list concatenation of names 1 and names 2. Binding elision element. Elision binding element 1. Capital R. Return bound names of binding element. Binding property. Property name. Binding element 1. Return the bound names of binding element. Single name binding. Binding identifier initializer opt1. Return the bound names of binding identifier. Binding element. Binding pattern initializer opt1. Return the bound names of binding pattern. 2. ECMA International 2024. For declaration, let or const for binding 1. Return the bound names of for binding. Function declaration. Function binding identifier. Formal parameters. Function body. 1. Return the bound names of binding identifier. Function declaration. Function. Formal parameters. Function body. 1. Return default. Formal parameters. Empty. 1. Return a new empty list. Formal parameters. Formal parameter list. Function rest parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of function rest parameter. Return the list concatenation of names 1 and names 2. Formal parameter list. Formal parameter list. Formal parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of formal parameter. Return the list concatenation of names 1 and names 2. Arrow parameters. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let formals be the array formal parameters that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return the bound names of formals. Generate a declaration. Function binding identifier. Formal parameters. Generate a body. Return the bound names of binding identifier. Generate a declaration. Function. Formal parameters. Generate a body. Return default. Async generate a declaration. Async function binding identifier. Formal parameters. Async generate a body. Return the bound names of binding identifier. Async generate a declaration. Async function. Formal parameters. Async generate a body. 1. Return default. Class declaration. Class binding identifier class tail 1. Return the bound names of binding identifier. Class declaration. Class tail 1. Return default. ECMA International 2024-93. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Return the bound names of binding identifier. Async function declaration. Async function. Formal parameters. Async function body. Return default. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Member expression arguments. Let head be the async arrowhead that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Return the bound names of head. Import declaration. Import clause from clause. 1. Return the bound names of import clause. Import declaration. Import module specifier. 1. Return a new empty list. Import clause. Imported default binding. Namespace import. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of namespace import. Return the list concatenation of names 1 and names 2. Import clause. Imported default binding. ng. Named imports. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of named imports. Return the list concatenation of names 1 and names 2. Named imports. Return a new empty list. Imports list. Imports list. Import specifier. Let names 1 be the bound names of imports list. Let names 2 be the bound names of import specifier. Return the list concatenation of names 1 and names 2. Import specifier. Module export name as imported binding 1. Return the bound names of imported binding. Export declaration. Export from clause. Export named exports. Return a new empty list. Export declaration. Export variable statement. Return the bound names of variable statement. Export declaration. Export declaration. Return the bound names of declaration 94. ECMA International 2024. Export declaration. Export default hoistable declaration. Let declaration names be the bound names of hoistable declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default class declaration. Let declaration names be the bound names of class declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default assignment expression. 1. Return default, 2.2 static semantics. Declaration part. The syntax-directed operation declaration part takes no arguments and returns a parse node. It is defined piecewise over the following productions: hoistable declaration, function declaration, return function declaration, hoist generator declaration.
I don't know. I want to I started replacing stuff and like getting into how stuff is set up, whatever, trying to figure out again. And I want to run a speed test to compare my JavaScript Engine whatever to Chrome. So I had chatbot output some script or whatever.
Defined piecewise over the following productions: lexical declaration, let or const binding let.
Because technically, well, I have a speed test, whatever, and it's
formal parameters, function.
It's really complicated.
Binding identifier, formal parameters, generate.
And it relies mostly off
async generator declaration, async function.
C syntax, arrays of arrays, whatever, not sparse arrays. So I don't every allocation is as big as the biggest number in it, and stuff like that. It's simplified. So there's certain operations that are faster than other ones. So if I make an array in my JavaScript Engine and I make it pick an integer 10 million, it'll allocate an array that big. So I use reasonably sized arrays, and then it does grow and expand, but whatever the biggest number is what the array size is. So that's like one of the things I'm gonna add to it with the newer. I spent like a year making a memory manager, so I'm gonna attach that to the JavaScript Engine I have now, and then all the sparse trees or sparse data collections, they will first go through that layer, and then it'll go to the memory. So I can pick like a granular size. So if you like set a key at like 10 million, it won't allocate that much memory. And if you pick keys that are close together, I can pick a granular amount or whatever, and only like fill the area in the array between two numbers or two keys, whatever, in the array if they're a certain distance, or if there's a loop. I also have I don't want to like explain everything, but I have yeah, I'm not gonna explain it all. I have like little tricks or whatever to detect and determine the direction that memory is being added to certain data types, so I can strategically resize things and use the new memory that's being resized to and the old one, the old location, whatever, like at the same time, and then it keeps track of that, and then it eventually drops the old one, and it does get kind of complicated if it like expands and expands. So I don't know, whatever. I want to make, or whatever, so basically I asked Chatbot to make a little speed test, and I think it's like actually okay for like a speed test or whatever, because I would never make code ever that looks like what it gave me. Like, I don't know. I would never write code like this because it's really slow. Like when I look at it, I'm just like, whoa. So I think it's a good test because since I wouldn't ever write code like this, it if I test it in my JavaScript engine, I don't know. I think it'd be like a good identifier. I want to make a couple more tests too, because I have like a really large test that it takes hours in the web browser to complete. Like I'm talking
nodes. It is.
I'm talking hours, like 60 minutes, 60 minutes, 60 minutes. Like it takes a really long time, and there's like a huge speed difference. Even in like small little tests, the speed's like really huge gap. But that's like a small speed test and like a really big one. I didn't do like this Cody or whatever. I didn't do like, I don't know what to call it, like a slop code test to see if like slop code or whatever is going to be more efficient too. Because it could be possible that this somehow happens to run extremely slow. I doubt it, but I want to just test to be extra certain. Because this is, I wrote this 8 years ago. And I can look at the number outputs that I have. Like I saved a log of the times and stuff. So I know it's faster, but I want to like run to test just so I can be like super extra certain, because it's I don't know. If it ends up not being faster, I will look like a total idiot. Like a seriously total idiot. So I just want to double check really quick, or whatever, to be like extra certain that like, I don't know, I think you get the point. So I'm gonna like try to convert this test function over onto this computer. I tried to find, it's not like straight up currently whatever.
I see.
Like 1-to-1 conversion. There's like, I have to like separate it out a bit, and then there's a scope and stuff, like it doesn't look exactly like C when I put it in my engine. I need to like organize it or whatever. So I tried to find a couple examples of other test things, and I don't know, I'm gonna try to run it though and compare it against Chrome, this script, whatever. So I'm gonna like do that. I was doing the types, but I just wanna test to be certain, because I'm finally at the point where I can find all the parts of the engine now. I kind of have a overview of it that I can kind of remember. So I just want to make sure that the speed and stuff, like I can see the numbers, I have them saved in notes. I just want to make sure, like, I don't know, there's no way it's not true anymore, but it seems it's extreme, like really, like, I don't know. So I don't know, I'm like test it really quick. I almost don't believe it. So if I run this, then I will feel like I'll be like, phew. I don't know. So that's what I'm gonna do, and then I'll get back to the types tomorrow. I'm gonna attempt to convert this. So I'm gonna like stop talking and do this, whatever.
Turn a new empty list. Export declaration. Export declaration.
Like, I'm like 9,000% sure my JavaScript engine is gonna be faster. I just don't know how much. Because it also depends on the C compiler. Because I put the JavaScript engine in C, so I like I don't know. It's in C, so the optimizations that the C compiler does, if it's a pattern of operations that the C compiler is not set up to handle, or that they choose to ignore, which they do sometimes, a lot of times, then it won't optimize certain things, and this block of code is so horrible that I think the C compiler will be able to optimize it. Because, I don't know. It's, really technical. So I just want to make sure I'm gonna like run this test. And then I will feel, like, I don't know. I just need to be like guaranteed and test this really quick. Whatever really quick means, this might take a bit to like convert. I don't know if I found I also have to like wrap all the stuff that I'm putting in to test this now in defined guards, so I don't mess up what I have right now, because right now it like does a specific order of operations, so it logs out. If I mess that up, the logout won't match. It'll be hard to tell if something ever gets messed up. So that's what I'm gonna do. I've been kind of waiting to test something, because I'm like, I don't know. I'm gonna test some whatever.
Declaration of assignment expression
And then be like, done for now. And I guess I'll like finish up the types next stream. There's not that many left. I thought there was a lot. And I need to like update all the files. I picked like 124 of the ones that are like actually being used, and it's gonna be a pain to like update them later. So I think I'm gonna get the JavaScript engine running. After I get the 64-bit arithmetic, I'll make the game demo still, and then I'm gonna have to go through the other 200 something files and then replace the types, and also get the address arithmetic. So that they're not like in a state where I have to like come back to it later and then do it. And I don't know, I'm gonna make the speed test, whatever.
Declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. 1. 2. If the statement list is present, return the var declared names of statement list. Return a new empty list.
I just like type it up by hand from this other computer. I'm gonna have to like find a hard drive or a flash drive or something. I don't want to like keep plugging stuff in to this computer. Otherwise it's not like an offline computer if I'm constantly transferring files to it. So I have like a couple hard drives, whatever, or flash drives. I don't know, I plug them in and then I don't plug them back in after I use them once. I have like a couple left, and then I don't know. I don't want to waste them on text file.
Try block catch finally. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Let names 3 be var declared names of finally. Return the list concatenation.
So, I don't know. That's what I'm gonna do. I hope, if this goes on for like 40 minutes, I'm gonna give up. Because I have to like it's complicated. I gotta like find a whole bunch of stuff and then like a template, basically. It's just like a conversion. It's not straight up JavaScript to C. There's intermediate steps, whatever. And it's really annoying to do it by hand. That's why I need a parser. And I'm gonna make a parser, I think, like at the end after I meet the standard. So as I'm going through the standard, I'm gonna have to like manually freaking pull apart JavaScript and reassemble it in this like pulled apart structure to make it run in C. It's really annoying to do. That's why, like, I don't know. It's like really annoying. I hate this. I should make the parser first. That's gonna take forever. And I wanna like tie the parser in with other things, so I wanna wait till the very end and I can make like a one size fits all parser, so I don't waste time setting up for like one specific thing and then have to like modify or make a second parser or third parser. So I want to like, I don't know, I'm gonna just type up this stupid test function and then speed test whatever on this computer.
Declaration 1. Return variable declaration list, variable declaration list, variable declaration. 2. Let declarations 1 be var scope declarations of variable declaration list. Return the list concatenation of declarations 1 and variable declaration. 04. ECMA International 2024. If statement. If expression statement else statement. Let declarations 1 be var are scoped declarations of the first statement. Let declarations 2 be var scope declarations of the second statement. Return the list concatenation of declarations 1 and declarations 2. If statement. If expression statement. Return the var scope declarations of statement. Do while statement. Do statement while. Expression 1. Return the var scope declarations of statement while statement. While. Expression statement 1. Return the var scope declarations of statement for statement 4. Expression not. Expression not. Expression not statement 1. Return the var scope declarations of statement for statement 4. Var variable declaration list. Expression not. Expression.
The program I'm using to like pixelate the screen. I don't know, I think like the default is the least distorted version. I don't want to like duplicate the desktop because it might mess up Sublime if I change the number of monitors plugged in. So I gotta like use this screen pixelating program to like view the other monitor on this other monitor. So I don't know. I'll just pick whatever's like, it doesn't matter. It's just whatever.
4. var for binding of assignment expression statement for await. var for binding of assignment expression statement. Let declarations 1 be for binding. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2. Note this section is extended by an XB. 3.5. With statement. With expression statement. Return the var scope declarations of statement. Copyright sign. ECMA International 2024 105. Switch statement. Switch. Expression. Case block 1. Return the var scope declarations of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, let declarations 1 be the var scope declarations of the first case clauses. Else, Let declarations 1 be a new empty list. Let declarations 2 be var scope declarations of default clause. If the second case clause is present, let declarations 3 be the var scope declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses. Case clause. Let declarations 1 be var scope declarations of case clauses. Let declarations 2 be var scope declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var scope declarations of labeled item. Labeled item. Function declaration 1. Return a new empty list. Try statement. Try block catch. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of finally. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Let declarations 3 be var scope declarations of finally. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch. Catch parameter. Block. Return the var scope declarations of block. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the top level var scope declarations of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top level var scope declarations of statement list. Concise body. Expression body 1. Return a new empty list. Concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top level var scope declarations of statement list. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let declarations 1 be var scope declarations of module item list. Let declarations 2 be var scope declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return var scope declarations of variable statement. Return a new empty list. ECMA International 2024 107. 8. 2. 8 Static semantics. Top-level lexically declared names. The syntax-directed operation top-level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. Let names 1 be top-level lexically declared names of statement list. Let names 2 be top-level lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax-directed operation. Capital T, O, P, capital L, E, V, E, L, capital capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top-level var declared names. The syntax-directed operation top-level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. Let names 1 be top-level var declared names of statement list. Let names 2 be top-level var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 108. ECMA International 2024. Note at the top level of a function or script. Function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, return top-level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement. Label identifier. Labeled item. Return the top-level var declared names of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top-level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 static semantics. Top-level var scope declarations. The syntax-directed operation top-level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be top-level var scope declarations of statement list. Let declarations 2 be top-level var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement, return top-level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the top-level var scope declarations of labeled item. Labeled item. Statement. If statement is statement, labeled statement, return top-level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. Copyright sign. ECMA International 2024 109. 8.3 labels, 3.1 static semantics. contains duplicate labels. The syntax-directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement list item. Let has duplicates be contains duplicate labels of statement list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of statement list item with argument label set. If statement, if, expression statement, else statement. Let has duplicate be contains duplicate labels of the first statement with argument label set. If has duplicate is true, return true. Return contains duplicate labels of the second statement with argument label set. If statement, if, expression statement, return contains duplicate labels of statement with argument label set. Do while statement, do statement while. Expression, return contains duplicate labels of statement with argument label set. While statement, while. Expression statement, return contains duplicate labels of statement with argument label set. For statement, for. Expression statement, for. var variable declaration list. Expression statement for. Lexical declaration expression statement. Return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement, for. Left-hand side expression in expression statement, for. var for binding in expression statement, for declaration in expression statement, for. Left-hand side expression of assignment expression statement, for. var for binding of assignment expression statement, for declaration of assignment expression statement. For await, left-hand side expression of assignment expression statement. For await, var for binding of assignment expression statement. For await, for declaration of assignment expression statement. Return contains duplicate labels of statement with argument label set. Note this section is extended by an XB 3.5 with statement, with expression, street. Statement. Return contains duplicate labels of statement with argument label set. Switch statement, switch. Expression, case block. Return contains duplicate labels of case block with argument label set. Case block, 1. Return false. Case block, case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains duplicate labels of the first case clauses with argument label set is true, return true. If contains duplicate labels of default clause with argument label set is true, return true. If the second case clauses is not present, return false. Return contains duplicate labels of the second case clauses with argument label set. Case clauses, case clause. Let has duplicates be contains duplicate labels of case clauses with argument label set. If has duplicates is true, return true. Return contains duplicate labels of case clause with argument label set. Case clause, case expression, statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Default clause, default, statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Labeled statement, label identifier, labeled item. Let label be the string value of label identifier. If label set contains label, return true. Let new label set be the list concatenation of label set and label. Return contains duplicate labels of labeled item with argument new label set. Copyright sign, ECMA International 2024 111. Labeled item, function declaration 1. Return false. Try statement, try block catch. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of catch with argument label set. Try statement, try block finally. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of finally with argument label set. Try statement, try block catch finally. If contains duplicate labels of block with argument label set is true, return true. If contains duplicate labels of catch with argument label set as true, return true. Return contains duplicate labels of finally with argument label set catch parameter block. Return contains duplicate labels of block with argument label set function statement list empty 1. Return false class static block statement list empty 1. Return false module item list module item list module item. Let as duplicates be contains duplicate labels of module item list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024 block. Statement list item. Declaration. Return false. Statement list item. Let has undefined labels be contains undefined break target of statement list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of statement list item with argument label set. If expression statement else statement. Let has undefined labels be contains undefined break target of the first statement with argument label set. If has undefined labels is true, return true. Return contains undefined break target of the second statement with argument label set. If expression statement. Return contains undefined break target of statement with argument label set. Do while statement. Do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression statement. Return contains undefined break target of statement with argument label set. For statement. 4. Expression statement.
None of the keyboard shortcuts I use work. Whatever.
Statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5. Break statement. Break. 1. Return false. Copyright sign. ECMA International 2024 113. Break statement. Break label identifier. If label set does not contain the string value of label identifier, return true. Return false. With statement. With expression statement. Return contains undefined break target of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains undefined break target of case block with argument label set. Case block. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains undefined break target of the first case clauses with argument label set as true, return true. If contains undefined break target of default clause with argument label set as true, return true. If the second case clauses is not present, return false. Return contains undefined break target of the second case clauses with argument label set. Case clauses. Case clauses case clause. Let has undefined labels be contains undefined break target of case clauses with argument label set. If has undefined labels is true, return true. Return contains undefined break target of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, Return contains undefined break target of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Label.
Actually, I think I'm like done for the stream. It's already been like 20 minutes. I'll do this tomorrow. And then I'll like get the rest of the types, whatever, and then download what was it? Remember those stupid window managers that open the window that OpenGL will output to or whatever. I can't remember what they are, it doesn't matter. Like GDW, I don't know. I'm done for now. I'll post this stuff tomorrow.
Try block catch finally. If contains undefined break target of block with argument label set as true.
I gotta find a couple more things to like make some of the operations that are needed. It's probably gonna take me like 20 minutes to like dig through the source code and find it and then paste it. I don't know, I'm like thinking of a whole bunch of stuff right now. I need to make an official to do this and then like follow it. So that's the first thing I'm gonna like do tomorrow, I guess. Make a to-do list, and then I'll do all the things I said a couple minutes ago. So that's it for now, I guess. I feel like I accomplished nothing this stream, but I did. I just planned things out, which is basically the same thing as doing them. It takes the same amount of effort, but not really, because it's alright, whatever. Peace. I'm gonna I'm just thinking whatever. But I'm gonna let the stream run on for like 10 more minutes because the stream doesn't end. So if I let it blah 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 run on for 10 minutes, it might send the whole stream in. Peace.
Twice over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block statement with arguments iteration set and ECMA International 2024 115, breakable statement, iteration statement. Let new iteration set be the list concatenation of iteration set and label set. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of iteration statement with arguments new iteration set and statement list. Statement list item. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list with arguments iteration set and if has undefined labels is true, return true, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list item with arguments iteration set and if statement, if expression statement else statement, let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the first statement with arguments iteration set and if has undefined labels is true, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the second statement with arguments iteration set and if statement, if expression statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and do while statement, do statement while, expression, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and while statement, while, expression statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and for statement 4 expression statement 4 var variable declaration list expression statement 4 lexical declaration expression statement return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and for in of statement 4 left hand side expression in expression statement 4 var for binding in expression statement 4 for declaration in expression statement 4 left hand side expression of assignment expression statement 4 var for binding of assignment expression statement 4 for declaration of assignment expression statement for await left hand side expression of assignment expression statement for await var for binding of assignment expression statement, for await, for declaration of assignment expression statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set end. Note this section is extended by an XB. 3.5 Continue statement. Continue. 1. Return false. 116 ECMA International 2024. Continue statement. Continue label identifier. If iteration set does not contain the string value of label identifier, return true. Return false. With statement. With expression statement. Return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set end. Switch statement. Switch expression casum lock return capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of case block with arguments iteration set end. Case block return false. Case block case clause assopt default clause case clause assopt. If the first case clause is present, then a if capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the first case clauses with arguments iteration set and is true, return true. If capital C O N T A